Is evolution a scientific fact? Well, if so, bring your scientific facts. I invite you to join the stream and share this evidence for evolution. And I just want to play a short opening video, some short opening music to just say what I think is often presented as evolution evidence, which really isn't.
Kind of like a person. Monkey look kind of like a person.
Monkey look kind of like monkey look kind of like monkey look kind of like a person. Monkey look kind of like a person. Monkey look kind of like a person. Monkey look kind of like monkey look kind of like monkey look kind of like a person.
Monkey look kind of like a person.
Okay, so this is the evidence I often hear for evolution, but I don't think I really look that much like this chimpanzee. I don't think any person really looks much like a chimpanzee or any ape, but this is the evidence that seems to be compelling to people. Anyway, I want to start by sharing some evidence against evolution, and this will be very quick. The evidence against evolution, one thing is our DNA. So DNA is a code. DNA is not just any code, it's the most fantastic code that we have ever encountered. And codes don't write themselves. We know this from many observations of the world, and you could do 1,000 more experiments and you would find that codes do not write themselves. Codes don't write themselves. DNA is a code. DNA did not write itself. DNA did not come about by natural processes. There is no natural process that can bring about a code, especially one like this. So everyone knows that when you use a computer, you are experiencing the benefits of code. But the codes that have been used to write your software did not write themselves. They needed a programmer. And somebody could say, well, AI can do it. Well, AI was also programmed. AI needed a programmer to start out with. And actually, DNA code is more like AI than just a normal computer code, because DNA actually has the ability to repair itself, change things. And so DNA is more like AI, but AI needed a designer. You would never say that code that runs AI is that it wrote itself by natural processes. There's no natural process that can bring that about. Now, some people will say, oh, natural selection can do that. There is nothing in the environment that wants a code to come about. A code in and of itself does no good. You could have, and I just did this random string of letters, and this is just a random string of letters, and it has no desire to become information. There's nothing environmental that would want this to become coded information. It will never become coded information through environmental processes. There's no driver that would cause in the environment to want to put information into a code. So there's just absolutely no way that DNA could have built itself. We have no scientific observations that a code can build itself. So if you believe that right now, if you believe DNA came about by natural processes, you're believing something anti-scientific. You're believing something that actually goes against science. You're giving supernatural powers to natural processes. So, all right. If anybody wants to join and share their thoughts, I welcome you. And right now I'm going to welcome Junior. Hey, Junior. Good to see you. Glad you're here.
Hey. So yeah, nice to be back, and lovely little, exactly just like you said, code doesn't come about like that, so very, very nicely said. And yeah, to this day, no evolutionists have an explanation to that, so they struggle because it's not true, because naturalism is not true. But anyway, So yeah, nice to be here, and I guess yeah, I guess I can share some stuff I wanted to share.
Great. Yeah, let's do it.
So present, and then share screen.
I'll put these comments up while you're sharing I'm waiting for your screen. It says, Answers in Atheism says no string of DNA is impossible by natural means. Well, you're making an assertion, but what we need is evidence. From what we see, it is impossible by natural means. Okay, are you ready, Junior?
Yeah, yeah. So basically, I wanted to focus on. I tried to make this somewhat fast. I tried to focus on the. You can see my screen, right?
Yep.
So I tried to focus on the fact that where did the heavy elements come from? There's two options. Did it come? Were they created by the slow natural process, like the evolutionists claim? Did they came from supernova, like stars and such? Because in their view, the reason why we have uranium, thorium, all the heavy elements in the Earth today is because it came from supernovas. Well, okay, sure. So there's that option, or there's the option that these elements were created quickly, catastrophically. So let's see where the evidence leads us in this. So now we know right here, Nature. This was published in Nature. Um, Scientists saying basically we have no spectroscopic evidence that heavy elements have truly been produced. This is then admitting that they don't actually know. So all of these science
Wow.
papers saying, we already know that heavy elements came from. No, they don't know. It's an assumption. So all these papers can be ignored because it's an assumption, just like evolution is an assumption. So that's why now they're trying to say, okay, so maybe it's coming from a neutron stars merger, right? Neutron stars merger, which is like when two neutron stars merge together. But it's a rare event. It's a rare event, really, really rare event. So basically, you're telling me that all the heavy elements we have now came from then, just then? Okay, I mean that's really implausible. But even if I grant you that okay, sure. So let me grant you that, even though this is silly, let me grant you that the heavy elements came from neutron star mergers. Okay, that means that all of the dust that came from these events, right? All of the dust, all the heavy elements that came from these events, they're gonna be part of what's gonna create Earth in the secular model, right? So Earth in the secular model was created by a lot of dust that was just, I don't know, spinning or whatever it is that they say, merging together slowly over billions of years, and the sphere was getting bigger and bigger, right, from the dust. And yes, the secular model of Earth formation states that the dust and material that are created to form our planet was already contained radioactivity elements. Ah, interesting. So basically, all the dust that formed the Earth already had radioactive elements. Interesting, which came from those stars, basically. So what does that mean then? That means that the core of the Earth, the mantle of the Earth, should have, it should have a lot of uranium in there, right? It should have a lot of radioactive elements in there. Uranium, thorium should be mostly on the mantle because, that's how the Earth was formed. So, bit by bit, the sphere was getting bigger, right? So, yeah. However, is that true? Is most of the uranium and thorium on the mantle? Well, let's see. 90% of uranium thorium are concentrated in the continents.
Hmm.
Uranium, thorium, potassium are the main elements contributed to natural terrestrial radioactivity. All three of the radioactive elements are strongly partitioned into the continental crust. So it's not even just the most of the uranium is not in the mantle, but 90%? 90% of all uranium thorium are in the continents. Like this is too specific. just goes against the secular view of Earth's formation by radioactive dust. This is very specific. It's only on the continental crust that most of the uranium thorium is. The flood model can explain this. I will explain this later. If I don't have time right now, I will explain later. But the flood model can explain this. Secular model of slowly forming Earth cannot account for this data right here. Basically, so oh yeah, it gets better. It gets better. Australia's uranium. On the basis of the data, 2019 data, Australia has 28% of the world's uranium resources. So it gets even more specific. Not only is just on the continents, 90% of our uranium on the continents, but 28% in Australia alone, which is like so uniform and specific. Anyway, so and he
Yeah, we're getting some comments related to this. So Jeffrey Green says you're just going off your own hunches and hoping that your audience is too dumb to catch on. Actually, what I'm trying to do, and I think what Junior's trying to do, is awaken people to the storytelling that has gone on and hopefully awaken them to common sense and help them see that the story you've been told is just that. It's a story and it's being passed off as science. But,
exactly,
so that's the problem.
exactly,
And
and
so, Jeffrey,
and
you said, sorry, go ahead, Junior.
oh no, sorry, I didn't want to talk. One thing they'll try to say is, no, but uranium is not gonna sink to the bottom. Uranium is not gonna sink to the bottom anyway because uranium doesn't chemically bound very well with the mantle minerals. And yes, to a degree that is true, but you're missing the point. Your model says that the Earth was formed with dust that was already radioactive. So if that dust is slowly making a sphere bigger and bigger, by definition, the mantle and the core should have uranium and thorium because that's how the Earth was formed in your model. So, don't just say, oh, the uranium is not going to chemically bound and that's why the uranium is not going to sink to the bottom. No, that doesn't work because your model doesn't see this happening. Uh, eh, but yes, do you want me to carry on, Rebecca, or you want to
Oh,
say?
yes, yes. And Jeffrey, we are not saying that science is wrong. We're calling people to look at our scientific observations. And so I think, and to separate what our scientific observations are from storytelling that goes on. And there's a lot of storytelling about how the elements formed and about how even the solar system formed. So anyway, go on, Junior.
Yeah, so the point I was trying to make there with this data is that all the 90% of the uranium is only on the crust, no, not just on the crust of the Earth, but only on the continental crust, really specific. Now, like I showed before, 28% only in Australia, very specific again. Now let's look at the ocean. Distribution of uranium in the oceanic rocks. Average uranium concentrations in basalts from holes, and just lists a number of places here. 0.28 ppm, 0.19, 0.2019, basically very low. Ppm is like something like a per meter something. I need to look it up. I don't recall now the ppm. But basically it's like it's a measurement, right, of how much uranium is there. And basically not even one point, just 0.28. That's how much on the oceans, guys. How much on the oceans. Let me take that off now. And another one right here. Uranium content on the oceanic upper mantle. Another paper right here. Whole rock uranium concentrations vary from 0.19.070 ppm. So this is the uranium on the ocean. Let's look now at the uranium amounts in the crust. Here I have a paper. Radiogenic heat production in the upper third. So, really, close to where we are, basically the upper third of the continental crust. From KTB is the name of the place, basically, where they done this experiment. So continental crust, Yeah, this is the key word right here. How much uranium do we find on the continental crust? And when you look at this graph here, hold on a second. So when we look at this table, uranium here is represented by Cu. Cu, yeah, uranium is Cu in this table. Foil is this Th symbol right here. This MbGn is just different types of rocks. Mb is gneisses, and the Gn is the basically the other type of rock. This is just different types of rock. Basically, and O just means like the representation of O, the average basically heat production. And how much do we find on the continental crust? Uranium 1.2 plus 1.0, 2.8 plus 1.0, and thorium, even more thorium. Thorium is like way higher here, 8.7 compared to the continental crust, which I just showed, which was like 0.19, whatever. So yeah, it's true. Most uranium, like the phrase says, 90% of the uranium is indeed in the continental crust. The flood can explain this. Secular models cannot account for this. I will explain that in a second. But now, how much percent of the continents is how much of the Earth is covered by sedimentary rock? 73%, and this is really important, by the way. Sedimentary rock. Why is this important? Because sedimentary rock is, it's formed by sediments, right? So, flood waters, for example, can create sedimentary rocks because, sedimentary rocks is created like this. You need water, you need pressure, you need sand, mud, these things create sedimentary rock. And 73% of the Earth. This is a great evidence for the flood, by the way. That 73% of the Earth's surface is covered in the sedimentary rock. Obviously, this is only talking about the crust, right? Like the continents and such. Very great evidence for the flood as well. Now, okay, so I just talked about how improbable is and how the data is against the secular version of the uranium that we see today and the thorium that we see today. Is there evidence for, is there a mechanism for creating these things in a catastrophic way, in a quickly way, not having to wait billions of years or whatever? Well, let's see now. There's a thing called earthquake lights. Really interesting. Basically, people have discovered that there's a connection with seismic activity, which is basically just tectonic activity, right? Like earthquakes and such. There's a connection between that and thunderstorms. So, really interesting. There's an active research on this earthquake lights. And this is really interesting because we know from the flood that things would have been moving catastrophically, like basically the continent splitting really quickly, really fast. Can you imagine the amount of thunder that was happening? Like you would have been crazy. The amount of thunderstorm and thunder would be insane. And this is really important because lightning is the main mechanism, and you're gonna see why right now. So, welcome to the Proton 21 studies on Ukraine. Now there's a laboratory in the US as well, but this is started in Ukraine with this fellow called Adaminko. He's the main name, by the way, Adaminko. So yeah, there's this paper here called "Exploring New Frontiers in Pulsed Power Laboratory: Recent Progress." Here they say, we present results of experiments using pulsed power facility to induce collective nuclear interactions, producing stable nuclei of virtually every element in the periodic table. This is insane. So basically, they're saying that basically it's like this. This is how the experiment is done. They use like a piece of copper, right? Like a piece of copper. Maybe I can the paper shows somewhere here. This is the machine, right? And they use a little piece of copper, yeah, little tiny, and then they basically they invoke a very powerful electrical discharge, like an electrical beam, to hit the copper. It hits the copper, piece of copper, and obviously, it's gonna shred it a little bit, right? It's gonna shred it because it's like a thunder hitting it. And they discovered that this creates basically all elements of the periodic table is created here, which is just amazing, amazing. I have another paper here. This is another paper of the Proton 21 laboratory. And here they basically show you the elements, some of the elements that was created. And by the way, lead is one of them. So you don't have to wait for uranium to decay to lead for billions of years. Yeah, so this is the piece of copper. And when it hits the copper, look at that. Amazing. So many elements from the periodic table is created in different ratios, different percentages. So, and this radioactive elements, but then they rapidly decay into stable isotopes, basically. But yeah, this is basically creating radioactive elements that quickly decay to stable ones. This is really amazing right here. And obviously, it also creates elements that are just radioactive, period. But anyway, people can go over this after if they want to see this paper in detail. And so going back to this real quick, how much power did they use for this? Estimations by orders of magnitude show that the energy demand is consistent with the expected energy input to the target, 100 joules. 100 joules is just a measurement of electromagnetism. This is nothing, by the way. They were able to create transmutation. By the way, Rebecca, maybe I should clarify this. Nuclear transmutation is when you take element, so say like copper, right? Like you have pure copper is made of copper atoms, right? It's made of copper atoms, only copper atoms. So the thunder hits it, the shock hits it, and it splits the atoms in many different pieces. So think of cards getting split. So the atoms get all split into different elements. That's what nuclear transmutation basically is, right? You take an element, you apply a thunder to it or whatever, and it splits apart into many other elements. That's what transmutation is. So they were able to create elements even having the uranium, even all of that done in the same day, all of that created in the same day. So now we know that thunder can create that. Now we know that thunder can be used for that, and they were able to do this of only 100 joules. Now, how much real thunder from nature has? 5 billion joules. Yeah, let that sink in for a second. So real thunder has 5 billion joules. But
June, you're really into young Earth creation, but most people are not going to have a clue about the significance of what you're saying. So can you break it down? Like, what is the point of this paper that you're showing us in this experiment as it relates to our, origins talk?
Exactly. So basically, we now have a mechanism to explain why we have uranium, why we have lead, why we have thorium, all of these radioactive elements. We have a mechanism to explain that. So no, we don't have to wait for uranium to decay to lead for billions of years or whatever. I understand that's the rate that we measure them today. The particles of uranium slowly decay into lead. I understand if you measure today, it would take billions of years. I agree. If you measure them today, but that doesn't mean that the uranium, the lead had to decay, from the uranium for billions of years. Now we know that these things can be created quickly in the same day. Catastrophically. That's the point. So this falsifies billions of years. This is the whole point, basically. So this is what the Proton 21 experiments are really incredible to show this, that you don't need you don't need billions of years to explain the presence of lead and the other heavy elements, the DOTA isotopes. So this is the main point. Now, can I quickly just tie this in to the flood? Mm-hmm. So basically, how do I think this could have happened in the flood model? There's this thing called piezoelectricity. It's a known phenomenon basically is piezoelectricity is the property that certain crystals have to become electric, have to become electric polarized when submitted to pressure or vice versa. In other words, it's the capacity of some materials to generate energy when it's squeezed or pressed. Interesting. So quartz, I don't know if you know this, but quartz is it's like a mineral inside of zircons, and quartz is so many different minerals have quartz on it, and quartz is piezoelectric. That means that if you squeeze into enough pressure, it will generate electricity. Interesting. Now we know that electricity can create nuclear transmutation as well, right? So that's what I think happened during the flood. As the waters were coming back and all the mud was drying up, right, after the flood, not only you still have a lot of thunder going on, which also creates transmutation, but also as the sediments was drying, pressure was increasing, more and more pressure as those sediments was drying and becoming rock. That's going to create piezoelectricity all over the world, right? We just saw that the earth is like 70% covered in sedimentary rock, whatever. Here 70% of the earth's surface, sedimentary rock. That explains really well why do we find the presence of radioactive elements of uranium, thorium everywhere. The flood explains this amazingly, really, really well, and also explain why there's more in the continents, specific in the continents, not even in the oceans, in the continents. That's exactly what we would expect in the flood model, because the flood deposit things in the continents. So I just find it really amazing how it all fits together. But anyway, Rebecca, that's all I wanted to say. I know it's gonna be
Awesome.
long. You can
Thanks
stop
for
now.
sharing. Okay. Well, we have some comments here. So Jeffrey says, even if you were saying something that was true about uranium, how long does it take for light to get here from a star that is 100 million light years away? Well, now this is really interesting because for a very long time, I would have said this was one of the best arguments against young Earth creation. Okay. I used to have two things that I said were very strong arguments against young Earth creation: radioisotope dating and the distant starlight issue. And in fact, the distant starlight issue is, the reason that my husband is not a young Earth creationist. Now, my husband doesn't believe in evolution. And if he did believe in evolution, I never would have married him because I just can't deal with that. But I can't deal with somebody having that level of deception that I'm that close to. But he doesn't believe in young Earth creation, and he would say the reason is still because of the distant starlight issue. But recently, I've come to realize that there's a good way of dealing with the distant starlight issue.
I can explain that if you want.
Okay, sure, go for it.
Yeah, so basically, I understand. I also used to think that I'm not surprised what many people still think that light, how comes, light, billions of years away, galaxies and such, that therefore, it took light billions of years to come here. Well, that's why it's important for people to do their research on that, because you see, it's you're basically using Einstein's synchrony convention. You're using Einstein's synchrony convention, which he assumes the speed is the same on both directions, basically. Basically in one way, and then to come back is the same. So if light took 10 seconds, basically the round trip is 10 seconds, right? Well, you would assume that it took 5 seconds to go, hit the mirror or whatever, and 5 seconds to come back. Well, have a read on Einstein's I think it's called the electro I forgot the name now. Something of electrodynamics of moving bodies. Yes, published in 1903, I think. Electrodynamics of moving bodies, where he talks about the nature of light, and he mentions that the one way is not measurable. You can't measure the one way. It is fundamentally impossible. It's not part of nature, basically, the one-way speed. Basically, since you cannot, basically you need two clocks to measure the one-way speed of light. You need two clocks, two chronometers or whatever. We have measured the round trip, mind. We have the round trip. We have measured, yes. So we know the round trip is really quickly. But what was it again? Like 300,000 kilometers per second or something like that. It's really fast, the round trip.
Well, I do it in miles because I'm from the US, so it's
Yeah.
186,000 miles per
Yeah,
second.
exactly.
But
Yeah.
yeah,
And-
I'm
and-
going to. But real quick, I'm
Yeah,
going
go,
to
go.
post a link in the chat right now. This will explain very well what our solution is to the problem of distant starlight. And this is a video talking about how we cannot measure the two-way speed of light.
The one
The
way.
one way, I'm sorry, we can only measure the two-way speed of light. We cannot measure the one-way speed of light. And this is the solution to this distant starlight problem. So how long does it take for the starlight to get to us from 100 million light years away? It's instantaneous.
Exactly, because it's a convention. It's not part of nature. It's not part of, if it's not part of nature, you cannot just say, no, hold on a second, but what about this or about that? No, nothing works. You can look it
Right.
up yourself. Nothing works. And therefore it's a convention, and you can't debunk it. You literally cannot debunk, even using relativity. And I have my own issues with relativity, by the way. But even using relativity that the atheists love to use, right? Einstein's relativity, you still cannot debunk a young Earth using Einstein's relativity, because Einstein himself said that it's a convention that we get to choose, a stipulation that I can make of my own free will, end quotes. So yes, evolutionists, how do you like that?
And now I know that it sounds wild, okay, and it goes against sort of like the convention, as you said, that we've been taught. Jeffrey says, you can't do it. That does not mean that the average high school class can't. But you have to understand, we're saying something that actually, this is something all scientists admit, like that deal with this. This is, we cannot measure the one-way speed of light. That is something known. We're not saying anything controversial with that. Now, it is still controversial for us to say that the light is reaching us from 100 million light years away instantaneously. Yes, that sounds controversial, but it works with physics. So there's nothing against physics that in what we're saying right now. So,
and people use it because it makes the math easier. That's why people use Einstein's convention, which assumes that it's the same in both directions. Makes the math easier. That's the only reason why they use that convention, really.
Howard F says, I can debunk the two-way time for light speed. I don't know what you mean by that, Howard. Is he agreeing with us?
I can debunk the two-way.
I'm confused. Anyway, Tom says God can create light in place for one thing. Another explanation is the stars were closer to us, and the light we are seeing from the stars is from when the stars were closer. Well, I personally don't think that with looking at our observations, I don't think the universe is expanding. I think it's static. So,
oh yes, I agree. Yeah, basically,
you do? Yeah.
you mean the fabric of space, right? The fabric of space, like how the Big Bang says, right? Like the fabric of space is expanding, right? That the observation is against that. Instead, all we observe is that galaxies are just moving away from us. That's all. It's just objects moving in space.
Well, they may not be, though. And that's the thing. The redshift, look, one interpretation of the redshift is that objects are moving away from us in all directions. Another interpretation is that there's the expansion of space. You're blowing into the microphone, so I'm going to mute you. If you can mute yourself when you're not talking, then you'll be able to unmute yourself. So, And then, but there are other interpretations of the redshift that they're not very popular right now because people have bought into the expanding space, but there are other interpretations of the redshift. Something can be happening to the light as it passes through space, such as through plasma, issues with, Wigner crystals, something like that. There's lots of different ideas about what may be causing the redshift that don't have to do with expansion of space or velocity.
I mean, yeah. There's actually redshift. There's so many ways to interpret. It's crazy. It really has nothing to do with like a Big Bang prediction, secular prediction, anything like that. We can, like you said, we can interpret redshift as being motion, or as just being really far away. Like the math changed a little bit, but it's still consistent with physics. You can just say that it's redshifted because of motion. That would mean that far away galaxies are moving even faster away from us than galaxies nearby. Or you can just say, like you said, it's distance. Basically, the wavelength of light is getting stretched, and that's what the redshift causes. That would mean that it's distance based, like you said, it's static, but it's because they're really far away. So many ways to interpret redshift has nothing to do with the universe being billions of years.
Yes. And that's the thing. We're not arguing against science here. We are challenging some things that are models in science. But isn't that what science really is about? Aren't you supposed to look at observations of the world, make hypotheses, and then test them? And unfortunately, in a lot of areas of science right now, it has gone off the rails as far as you don't have to even test it. You can just make up wild stuff and call it science. Howard, I'm so glad to see you.
Hey, hold on. My phone just rang, and I'm gonna.
Okay. Take your time. Anyway, and I'll suggest one of those.
Ready?
Okay, you're ready? Go ahead.
First, this guy who's saying that the thickest sediment accumulations on continents, and that's why we get all the radioactive elements in continents. That's just bull. The thickest sediment accumulations by far are on oceanic crust. So in the Gulf of Mexico, the thickest accumulation is about 18 to 20 kilometers. The same thing in the Niger Delta, the same thing in the Black Sea, and that's all on oceanic crust. And oceanic crust has almost no radioactivity. So there's absolutely no relationship between the thickness of the sediment accumulation and the accumulation of radioactive elements. So I just thought I'd make a comment on that.
Okay, so I guess I can respond. Yeah, it may be. Very well may be. I know on the Gulf of Mexico there is a very thick and big sedimentary. However, 90% on the continents, the sediments on the continents,
even close, not even close. In North America, probably 90% of the sediment is on the surrounding oceanic crust. Maybe 10, 15% is on the continental crust. The accumulation of the continental crust is very thin, typically 2 kilometers at most, maybe 3 in a few places. Whereas if you look at the offshore on the East Coast or offshore Alaska or offshore Gulf of Mexico, far more sediment. It's billions of cubic kilometers in the Gulf of Mexico. I think it's 2 or 3 billion cubic kilometers. Nowhere near that much sediment on land. So
So sediment.
Before you go on, Junior, is there anything we can do about the microphone situation? Because there's some noise, and I think, Howard, are you far away from your microphone? Is there any way you could bring it closer? Because I think that's where we're getting the noise.
I have stuff on my computer, so is that a little bit better?
I think so. I can hear you a little better. Yeah. Okay. Go on, Junior.
My computer was covered with books, and that may be part of the problem.
Okay.
So, anyways, I'm in the process of putting together a map for another project that has the sediment thickness for all of North America and the surrounding oceans, and the amount of sediment thickness on oceanic crust far exceeds what's on continental crust. So, if you were really
All surrounding the continents, yes. Do you realize how consistent this is with the flood model? All surrounding the continents.
why nothing in the Pacific? It's not surrounding the continent. It's in specific areas.
Oh no! I can I can show you that it's surround the specifically the mega sequences, the so-called mega sequences. They are absolutely surrounding the continents, yes, and actually in the continents a little bit as well, but surrounding that's consistent with receding waters
I'll tell
on the
you
flood.
that is not true. I'm a stratigrapher by profession. I've been doing this for 40 years. I know what I'm talking
Okay,
about. There is no.
okay. I guess I have to show you.
Wait,
Okay,
Junior, can you please let him speak without interrupting?
Let me finish
okay.
that statement. There is virtually almost no sediment thickness in the offshore in the Pacific. There is a huge sediment thickness in the Gulf of Mexico. There's a little bit less, but still a pretty good thickness off the coast of the east coast of the Atlantic, and then just on the western side of the Arctic, there's a pretty good thickness, but it is not continuous at all, and they're different ages. So the maximum thickness in the Arctic is Cretaceous and older, and most of the sediments in the Gulf of Mexico are the late Cretaceous and younger. So they're not even the same ages, and the mega sequences don't occur everywhere. I mean, this has been known for decades, and for you to dispute it shows that you're just not reading the literature and you're not honoring the data. These aren't interpretations; these are data.
I know they did. I know, yes. And you interpreting according to your secular view, and I want to show my view on this. Can I share
Well,
my screen?
how about this? Because right now we have a dispute about facts. If I pull up your screen right now, is it going to dispute what Howard is saying with like some kind of documented source?
Documented, so yeah, because I saved the screen. I did a screen share. I'm sorry. I took snippets of the paper. Let me find the paper itself.
And I mean, to be honest, I'm not really sure what difference this makes. Like,
Yeah,
Howard is correcting something that you're saying about the amount of sediments in the ocean versus the continents. And I don't really see is that really a problem?
no, because I understand his main point is talking about where the sediments are, basically. I can also answer that, but I would also like to talk about the uranium as well. Come back to the uranium after, but yeah, I can talk about the location of the sediments as well. So, for example, let me just. But anyway, while I'm searching here, yeah, please go on, Howard. You can
Well,
build
if
your
I
argument.
share my screen, I can show the map right now. If you'll allow me to share my screen, I'll just
Yep.
show.
Is that you? No, that's Junior. Okay. I don't see your screen to be able to be shared.
Is there something I need to do?
Did you share your screen?
How do I do that?
Okay, at the bottom, there should be a little computer icon. You can click that and it should give you options. Is it letting you share it?
Yeah, I just had to get through a few things.
Okay, there we go.
So this is not a complete map. I'm still working on it, but it is sediment thickness for the entire continent of North America. You can see the scale there. I haven't finished the Gulf of Mexico. It actually gets up to about 20 kilometers there. And you can see that in the ocean basins, the Gulf of Mexico, a little bit onshore in Texas, offshore, East Coast, a little bit offshore Arctic, but a lot offshore Alaska, and almost nothing offshore Pacific. and then look at how the thickness on the continents. There's maybe a couple small areas that get up to 3-4 kilometers, maybe 10 kilometers at most, but that's very, very small areas. And if you calculate the actual volumes, far and away, far more volume of sediment on the oceanic crust than on continental crust by like an order of magnitude. It's not even close. And so if your model of the origin of radioactive elements was correct, we'd see more radioactive elements in oceanic crust areas, and we don't. We just don't. Almost, because there's no granite, because almost all radioactive elements ultimately come from granite, and there's no granite in oceanic crust, and so there's, oceanic crust itself has almost zero radioactivity. So your model is wrong, based on not an interpretation. This isn't an interpretation. This is evidence. It's compiled from many different sources because there's no one map that shows all of this, but I have all the citations, you can look it all up yourself. But this is the actual distribution.
Okay. So can I speak on that?
Sure.
Yeah, so I very much respect you, Mr. Howard. Obviously, you have many years of experience on this field. But you must realize, Mr. Howard, that does not equals truth. That does not equal the truth. I understand you have your interpretation, but I can interpret this as the receding waters of the flood depositing all of that in the Gulf of Mexico. We cannot go back to the past. Sure, you can interpret your way, and I can interpret my way. And, that's why we need to look at more evidence. Otherwise, it's all interpretation of why the sediment is there in the Gulf of Mexico. We cannot go back to the past. I wanted to share my screen to show some really compelling evidence here for the flood as well. Sorry, go on.
I was not talking about the flood. You're changing the subject. The only thing I'm talking about is the district.
I will go to the uranium. I promise I will go to the uranium.
But Junior, look, I think it's important if we're gonna do this. Okay, somebody's mic is really loud, but it's really important if we're gonna hold on. Somebody's mic is loud. Howard, I'm gonna mute you because I think it's the noise coming from like the feedback. So we have to be honest about what's going on. If we say something and it turns out not to be true, then we need to say, okay, what I said about the amount of sediments is not true. So I don't want to move on to uranium. Unless like we are saying, okay, either we don't know if it's true or it looks like it might, you know what I mean? Like what's our response?
Okay. I'm gonna clarify. So 73% of sedimentary rock on the Earth's crust. Okay, I'm sorry if you understood it as I say on the continents, but on the Earth's crust. Okay. Now I was talking about the 90%. I was talking about on the continental crust. That was for uranium. Just to clarify that. Okay, so we don't get confused here. But yes, so the sediment specifically, just the sediment, that's on the Earth's crust, and it makes sense, right? Of course, it's going to be on the Earth's crust, right? 73%, of the Earth's crust is going to be, sedimentary, not necessarily on the continent. So I agree with you, Mr. Howard. I agree with you. Not necessarily in the continent.
You've muted me. Can I speak?
Oh, sorry. Yeah, I muted you because your mic was giving feedback, but it should be fine now.
I cut out. I had YouTube going at the same time. I cut it out.
Okay.
Get back to what you said. You said the thickest sediment accumulations were on continental or on the continents. That's what you said, and you said that's where the uranium occurs. And that statement that you made is false. There is no relationship between the distribution of the thickness of sedimentary rocks and uranium. Those two things do not correlate. Yes, there is a thin veneer of sedimentary rocks over most of North America, except for the Canadian Shield, but it's thin. And if your piezoelectric theory was right, we should find the greatest amount of piezoelectric charge or force or whatever where the sediment accumulation is thickest, and that's where the most uranium should be. And that is not true. That is a measurable thing. We've measured it. We know it. It's not true. That's the only point I'm making. I'm not talking about the flood. I'm not talking about anything else. Just your statement about the distribution of uranium. It does not work.
Okay. So I'd like to also share here my screen as well.
How do I stop sharing?
There we go. I got it.
Oh, I'm okay. I'm sharing already, right?
Yes.
Oh, okay. So it's not just pure electricity. They are, like I said, thunder as well. By the way, thunder, the Proton 21 experiment shows that thunder can create this nuclear interactions, right? Transmutations. But anyway, let me stick to just the sediments for now. You're disputing the sediments specifically. We have very strong evidence here. ICR has done a study on this, right? So for example, South America, it shows a progression, right? A very clear progression. The location of these sediments. Look at the locations. Look at their By the way, this is the mega sequences, they have different names, right? The different mega sequences.
Yes, I learned those as an undergraduate.
Yes. So basically the different mega sequence that we see shows a progression, like the higher you go shows a progression. And when you look at the map, and ICR has done an incredible job on this, when you look at the map, you see a very clear progression. This mister does not shows millions of years of local floods here and there. No. You can see this is a single event. It's a single event that happened, and that's why you see this progression of location to location within the sediments. And yeah, it's very consistent with the flood model, because after the receding waters, it's gonna deposit the sediments by the continental, by the beaches, basically around the continents. That's exactly what the flood model expects, and that's exactly what we see on every single continent. Every single
You're
continent.
not talking about uranium.
I know. I will go to uranium. Yeah, I will go to uranium.
First, do that first. That's what we're talking about.
Exactly.
Subject.
Well, obviously, you start to talk about the sediments. I'm talking about the sediment. But coming back to the uranium, so like I said, we have this mechanism now that we can account for the uranium and the thorium that we see. Now, keep in mind, just because this is the mega sequence, by the way, okay? This is the mega sequence. There is sedimentary layer in the continents as well. This is just accounting for the mega sequence. Mega sequence is basically many layers on top of each other, many. But there are sedimentary layers in the continent itself as well. But this map here is just showing the mega sequence. I know you're working on America or North America. I don't know in general. You said you're doing a study on North America or something. And then you showed a map there. And yeah, you can see that there's a lot. You said a thin layer, right? Well, sure, thin layer. Doesn't mean it's not a sedimentary layer there that has quartz on it. And quartz is piezoelectric. So not necessarily just by pressure that uranium can form. It can be other mechanisms as well. Maybe not just pressure. Maybe like lightning, thunder strikes.
But you said, I'd like to interject. You're changing your story. You said when you were talking to Rebecca that the thickness of the sedimentary column explains the distribution of uranium, and now you're totally backing off that.
You are misrepresenting me right now, because I did not say that as if it was like, oh, I only abide by this and this alone. So a little bit of misrepresentation there, but that's fine. I said that we have mechanism to account for it. I didn't say specifically what it was, but I said we can account for that. If anything, Mr. Howard, did you see that? Did you see that quote that I showed earlier, where the seculars themselves says that we're not even sure if supernovas can actually create, the heavy elements? Yeah, that's a problem for the secular view. That's a really big problem. This data right here, and by the way, this is South America. You want to see Asia? Okay, this is Asia, same progression.
Wait, I
This-
don't want to see more. I want to go to. We need to get straight about the uranium. What was the point you were making about the uranium? And let's talk it out.
Exactly. I think I kind of already, yeah, I think I kind of already said it. So
Well, people can go back and listen to the YouTube video where you said the thickness of sedimentary rocks explains the distribution of uranium.
that's one. That's one.
That is
I did not say I abide by this. Absolutely.
So why, if the sedimentary thickness is 20 kilometers in the Gulf of Mexico, how come there's no uranium there? None that I know of, anyways, or very little. There's a little bit, but not very much.
You just explained it. You literally just explained it. There is uranium there.
Where do you get those measurements from?
Did I say there's a correlation of thickness to the amount of uranium? I never said that. You saying that?
I think you said that. Rebecca,
No, I did not say that.
It's a little bit hard to remember because there's a lot that was said about uranium, but so the specific point about this I'm not sure about.
all right.
But
Well,
we can go back and watch it. But
Megan,
okay, so Junior, what are you saying about uranium now? What would not be misrepresenting your position?
Yeah, so basically like I said before, uranium did not come from stars. Uranium was formed catastrophically. It was formed very catastrophically. And the data and the sedimentary data shows there was a catastrophe, a global catastrophe. That's why I wanted to show more of the sedimentary data. That's why I went to the Asia page that you said you didn't want to see, because I wanted to show more that this was catastrophic, was not like a slow, gradual.
may I ask a question about that? How does thickness alone indicate catastrophe? Because you can get a thick accumulation slowly. The Mississippi River today sediments slowly to the Gulf of Mexico. Given enough time, you'll get enough thickness. So how can thickness alone indicate catastrophe?
Well, you see, it's not. How can I say? It's not. You need to look at the progression chart. I can link this to you after if you want. But the progression.
I
The
know
progression is quite clear here. It's not. If this was like random floods, random little floods happening here and there, millions of years or billions of years, you would not see a clear progression like this. All matching.
May I respond, please? So first of all, you have to recognize the origin of the megasequences. They were defined by a guy named Sloss in 1964, recognized first in North America and then other places around the world. And they are not random. Nobody's ever claimed they were random. Each megasequence is created by a single flood. Some of the floods were bigger, some of the floods were smaller. So the progression that you're showing is completely consistent with an ancient Earth. And these maps that Clary has made are nothing new. He's just duplicating work that's been done for decades. And all those maps you're showing are from Clary. And
Wait. You saying a global flood multiple times?
I would say, let me make clear that there is global flooding multiple times, but not necessarily covering every bit of the continents. But each mega sequence has, since the 1960s, been interpreted as a separate flood. Yeah, that
Interesting. Very interesting.
It's not new.
So,
This is
okay. So yeah, so that's why we have a cold slabs, right? That's why we have cold slabs underneath the earth with about 4,000 temperature difference from the slab.
I'm not a
That's very consistent with billions of years. Yeah, interesting.
No, because it's not possible to directly measure the temperature of those slabs. They're very, very hot. They use tomography to measure it, and those are at best estimates. So what we have when you look at the sediments inside the megasequences, what you see are paleosols, which are ancient soils which show thousands of years of weathering. You see coral reefs, which take time to build
That's
up.
just your. I can't. All that you're saying, sir.
You,
I can interpret in the young Earth.
you interrupted me. Let me continue.
Okay, go on, sir.
Coral reefs, the thickest coral reef I know of is the Capitan Reef, which is 1,000 feet thick and about 400 miles long, and it's all in situ. There are many other reefs scattered across North America. You also see embedded river valleys that are encased in the rock record, where you can see tributaries, and within the river valley, it's all terrestrial fossils. Outside of the river valley, the sediments that are being eroded are all marine fossils. So there are multiple lines of evidence for long periods of time embedded within the mega sequences, and you're ignoring all that evidence.
Okay, if you had multiple floods happening, well, first of all, you would not expect. You see the amount of things you have to ignore just to save the billions of years. Continents would not look like they would fit. They wouldn't, because erosion would absolutely distort everything. And when you look at the oceanic ridge and Africa and South America, they fit almost perfectly, showing that this time of erosion has not happened. So you have to ignore that. You see, this data right here, it's a data that we can both look at it and interpret our own ways. I interpret the young Earth way, you interpret your secular way. I understand that. However, if this is agnostic evidence, and by the way, you sure you can claim that many floods happen, nearly global or whatever, and happen many times. Okay, sure, fine. So we're looking at this evidence and we interpret different ways. So this is agnostic, right? Agnostic, because you can just interpret your own way.
Okay, so
That means
let me ask you point blank, how do you interpret the existence of soils in the rock record? It's not just that, let me finish. You weren't about to interrupt, but I thought you were.
No. Go ahead.
Let me finish. It's not just that soils exist in the rock record. It's that the range of soil types we see matches the range of soil types we see forming today, mostly due to different climates. We can measure how fast these soils form, and they take hundreds of thousands of years, and we see thousands of soils stacked, especially at the megasequence boundaries.
Okay.
And
So,
just
sorry.
that,
Go ahead.
just that one bit of data, anybody can go out in the field and look at it, and that alone is a nail in the coffin for a young Earth.
Did you say soil, right? You said soil.
Yes.
Okay. After, I'm gonna show you. When I link you a paper. Soil, all of these elements that people claim needs to take billions of years, literally created in a lab, like basically on the same day, like, or within a few days, by using pressure alone.
Show me a paper that says that. I know there you can create coal in the lab, but you can't create a soil. Not that fast. Show me
Yes.
that.
Okay. So.
Okay, well, why don't we let Sal say something here?
Yeah.
Sal, you jumped on, and we haven't heard from you yet.
I will just stop. Oh, you took my screen off, right? Yeah, take my screen off, Sis Rebecca.
Oh yeah, your screen is down. Do you need it?
Yeah, you can. I'm gonna come back after when I show the soil paper.
Okay.
But just a quick hello to Saul. Saul, big fan. I follow your channel as well, and
Thank you.
I know I don't know much about the transmutation and the Proto 21, but I know you know quite a bit about that. In fact, I learned from you some stuff about that. So maybe you can explain better about that side of things.
Oh, well, thank you for having me on, Rebecca. Very kind of you. Great to finally see you again after both of us were gone. Howard, it is a real privilege to hear from you. I was very, very impressed with everything you had to say. I am a young Earth creationist, but I don't get along that well with a lot of them because I think some of their arguments are way ahead of where the data are, and I think you have shown that in your many of your discussions. So the things that you raise troubling issues for are also bothersome to me. So people might ask why I'm a young Earth creationist. I guess part of it is intuition, and then also the trend of the facts over the last 40 years. So, I wouldn't say either side has a slam dunk. I give the advantage to old Earth right now, and that's where I stand. And I was very impressed with what you had to say, Howard. So at least wanted to have a chance to meet you.
I think it is a slam dunk that the Earth is old, just based on stratigraphy. I'm a stratigrapher. I've been doing stratigraphy for several decades. My main background is working as an oil company, where stratigraphy is incredibly important. In fact, the modern version of stratigraphy, called secret stratigraphy, was invented at an oil company, and it is by far the world standard today. And I teach it. This is what I do. I'm taking a group out to the Brook Cliffs, which is in Utah, in a week. And the evidence from stratigraphy is absolutely inconsistent with the young Earth. The soils, the reefs, the river valleys, there are so many myths that creationists propagate, like that terrestrial fossils are always mixed with marine. And the truth is that terrestrial fossils are almost never mixed with marine fossils.
Howard, we're having a hard time hearing you. Can you come closer to your microphone?
I'm not sure where my microphone is. It's somewhere in my computer.
Okay.
Can you hear me now?
We can. It's just there's a lot of noise with your, it's very hard to hear you.
I don't know why. It's completely silent here. But there are river valleys embedded in the rock record. We see these images in seismic. They're uncontroversial. Everybody outside of creationism accepts the fact that there are large river systems embedded in the rock record, and this is inconsistent with creationism. Everybody outside of creationism accepts that terrestrial fossils are, for the most part, not mixed with marine fossils, and they are associated with soils and with river valleys. And so I'm going to open this up and see if I know where the noise is coming from. It's a fan on my computer. Is it any way better?
A lot better. Yeah.
All right. I just opened up the screen. All right. I figured out what was going on. It was the fan on my computer. So anyways, there's and many other lines of evidence. The heat to produce oil is inconsistent. The roots underneath coals, creationists lie all the time and say coals don't have roots. And they do have roots. Almost all of them have roots, which shows that the plants were actually living there. So there are dozens of lines of evidence that are from stratigraphy, which creationists like to ignore, and that are inconsistent with the young Earth. You have to have an old Earth for that to happen.
Well, I wanted to say very much I appreciate all these points. I was raised a Roman Catholic and accepted evolution, old Earth, and had been then became an old Earth creationist for most of my life. Then I became a young life creationist, and then a young Earth creationist. Part of it was actually the physics that I started to study. So we should never neglect anomalies, and some of these anomalies do bother me, such as the magnetic fields. And this is a testable prediction. We still don't really have, despite all the numerous peer-reviewed papers, and by the way, the number of peer-reviewed papers is not necessarily a measure of our actual experimental evidence or how solid our theories are, but that magnetic field is decaying. That bothers me. There are issues. When I read the book Solar System Evolution, it was meant to defend an uncreated and evolved solar system. This is an evolutionary book. I have it in my bookshelf. After I read it, I said, this is nonsense, because after every page, it's like, this is a acute unsolved problem, and it makes more sense if it were specially created. Now, that doesn't necessarily mean that it happened recently, but as I started to see this trend, and then I also started to see it in cosmology. So,
can we get back just the magnetic field? I'd like to talk more about that.
Well, no, I would like to say this is where my intuition is, and then I'm seeing where species are going extinct so fast, the genomes are decaying. This is not consistent with an old Earth and old evolution. And that's the other thing. As I studied more of the biology, I realized evolutionary theory can't even hold up, even on the assumption of old Earth. So, I think also we still don't understand. I started, I studied cosmology, general relativity, quantum mechanics at graduate school, and nucleosynthesis is still not a solved problem, and it's still an open problem, and there are many avenues for it. So, I'm personally interested. Junior was asking about proton 21. That is one mechanism of transmutation, but we're finding possible others. And one of the fields I study is quasi-particles. And there may be alternate routes for transmutation. It is being studied, and there's good theoretical possibilities there. So, even though I would not say it's a slam dunk, there are disconcerting anomalies such as the biochemical evidence. I've talked to radiometric guys, and I said, well, look, the chemical dates don't seem to line up with the radiometric dates. And one of them, who's a professional at this, he said, you do have a point there. That's a number of
dates? What chemical dates? I don't know what that is.
Okay, the existence of peptide bonds, the lack of full racemization in the fossils. Marcos Eberlin, who's one of the top chemists on the planet, is a young Earth creationist because of the chemical dates.
So racemization, that one I know, and racemization does equilibrate over time. I've seen that happen.
Well, that's the problem. It shouldn't if it's still homochiral in a lot of, or partially unracemized. That is a problem. I've looked at beta.
So what I can say, you've brought up like 10 things and not let me respond.
Yeah.
So let me respond.
Okay, I'll let you respond.
What I can say is that every time I've seen an argument in an area where I have expertise, that argument is easily debunked. And so you've brought up a whole lot of things where I don't have expertise. I can't talk about physics. I don't know anything about physics, but we can talk about the decay of the magnetic field. The magnetic field has reversed many times. And so the fact that sometimes it's increasing in strength and sometimes it's decreasing in strength is completely consistent with what we know about Earth history. So that's not something special to
now the measured rate. Now with the measured rate.
I don't know.
Look at the measured rate, you find out that it was quite strong in the past. That's why the rate team did some really good work at that. I can link to you after if you want. And they found empirically, not based on.
Wait, there are two people talking. Hold on, there are two people talking, and I can't hear either one. Junior, do you have a point you want to?
I'd like to bring an argument and then how it can respond.
Okay.
So the rate team did a empirical work on that, actually verifying that it was quite fast in the past, and they found out that if you just go back a few thousand, like I don't know, 10,000 to 15 years, life wouldn't even be much sustainable because it's just that much stronger. The magnetic field is decaying. Not really consistent with the billions of years of decay. Also, you have no mechanism. You have no mechanism to account for the magnetic field having to recharge, right? For millions of years, like keep it recharged. Have no mechanism to account for that as well, because
let
Howard respond to that.
First of all, taking the rate of magnetic decay today and extrapolating back 10,000 or 20,000 years, that's not geologic. I mean, we know rates change through time, so that doesn't mean anything. Second, that we know from studying successive lavas that the magnetic field has strengthened, weakened, reversed, strengthened, weakened, reversed, and that has been established since the 1950s. So we know the magnetic field has reversed many times, and so at times it's going to be weakening, at times it's going to be strengthening. And it's taking one rate that you've measured over a decade and extrapolating it back in time, we know that cannot be correct, because the strengths of the magnetic field can be measured as they're preserved in successive lava flows.
Yes, I understand.
Wait, I want to ask a question. Hold on, I want to ask a question. What is the source of the magnetic field? What is the energy? How is it?
I'm not a geophysicist. I don't know.
God. But anyway, so basically, I understand, Mr. Howard. However,
Dr. Howard.
Okay, yeah, Doctor. with time, it doesn't matter if it goes up or down a little bit, the magnetic field. You must understand that with time, it's gonna reach a point where you don't have any more dust. Otherwise, you need to invoke a mechanism that somehow can replenish the magnetic field to such a large proportion that it's all gonna be fine again for billions of years. No, that doesn't exist. I can show you papers
Well,
of the RAID team. Every single objection has been dealt with. I can show you the objections if you want to read them after. You don't have a mechanism to recharge the magnetic field to sustain it for billions of years. So it doesn't matter if it goes up and down a little bit, up and down a little. Yes, we creationists, we agree that reversals has occurred. However, given billions of years, it doesn't matter how the reversals is going to reach a point where you do no longer have a magnetic field. That's the main point here.
Well, we can say that's not true just by looking at the rock record and the magnetic field that's preserved. There's no evidence. There's no evidence looking at the rock record that the magnetic field is getting weaker with time. And we have the evidence in the rocks. And we know that the magnetic field has reversed probably, the further back in time you go, the harder it is to find the evidence, but certainly dozens of times. And this is used for as a dating technique. You can use these reversals. And we know that when the reversals happen, there is a very brief period of time when the magnetic field doesn't exist, and then it strengthens again. Now, not knowing the mechanism doesn't mean a mechanism doesn't exist. I'm not a geophysicist. I have no idea how the core works. I know that the timing of the reversals isn't periodic. It happens at irregular intervals that no one has yet figured out. But that's just an unanswered question in science. It doesn't mean that it can't be figured out. It just means it has not yet been figured out. But we know from the past that the magnetic field goes to zero and then increases again. And this has happened dozens of times in the past. I don't know how many times. I haven't counted.
Okay. So the rocks would not tell you anything about that. Time, like I said, entropy is a thing, and time will make the magnetic field disappear given billions of years. Doesn't matter if it goes up and down, because you don't have enough, you don't have a mechanism to recharge it enough to actually last that long. You just assume that you don't know. So, it's an issue.
I'm not assuming anything. I'm just looking at the rock record. The rock record shows that it.
Yes, you are. You're assuming that it has lasted for billions of years when you can't.
As an outside observer, I hear an assumption both of you guys are making, but I want to give Sal an opportunity to jump in on this because he's making some comments about it. And then if he doesn't say what I'm thinking, I'll make a comment later.
So the thing is if you're locked into only one set of evidence, that results in confirmation bias. I've given a spectrum of things to consider, and you have to try to figure out how to explain those anomalies to squelch doubt. The problem is when James Tour, who's a top chemist on the planet, very high H index, same for Marcos Eberlin, when they're expressing their concerns about the chemical dates, they know rates of reactions and decay rates of these things, and they say it's not consistent with what we know about chemical kinetics. You can't just ignore that. And I've talked to a professional, and he's on my channel, and he said, yeah, Sal, you have a point there. These chemical dates are not consistent with our radiometric dates. And I said that I kind of saw that coming. So you can't say it's a slam dunk yet until you've started to explain these anomalies. You could say, well, the weight of evidence is for old Earth, but you can't say, well, we're going to discount all this other contrary evidence. I've seen evolutionary theory and abiogenesis theory overturned in my lifetime as evidence has come in, not by creationists, but by researchers in their own field. So some of this is starting to come apart. Same for the Big Bang and stuff in cosmology and string theory. I'm just pointing out, trying to restrict the discussion to stratigraphy is limiting the spectrum of things we should examine to make these considerations. So I would not say it's a slam dunk. Even if we have a 1% chance of being right, that's still something to consider. In the magnetic field, the physics of that have not been figured out. We know when we heat permamagnets, they lose their magnetism. We don't know how these planetary magnetic fields are generated. They do exist, but until we can actually take apart the Earth and see what's going on, we are all speculating just from what little stuff we could do on the surface. So we just don't know. And this whole thing about the magnetic field reversing over time, that's still some bit, I will admit, there's reversals and changes in intensity. But, all that layering stuff is still circular reasoning. We have had measurements since about the mid 19th century or late 19th century for the magnetic fields. It's decaying. That is a testable prediction. If it continues over the next few hundred years, in fact, I saw it on Wikipedia before they changed it. They said it should be gone in about 10,000 years. Unfortunately, we won't be alive at that time, but that is a testable prediction for future generations. We don't know what's causing it. It's going so bad right now. We're concerned about the ozone layer. It's causing climate change. And NASA is having these big holes in the ozone layer that they're attributing to the lost magnetic field. So if it had varied in the past so much, why do we still have an ozone layer when it was so weak?
Well,
it is unique to the era.
The reason I'm restricting my comments to stratigraphy is because that's what I know. And I'm not going to talk about things I don't know. I don't know anything about how the ozone works. I don't know anything about geophysics. I know stratigraphy. So what I can say, again, every time I've seen a young Earth argument in an area where I have expertise, it has been wrong. Now, when you said circular reasoning, what do you mean? Because you keep going on to other topics. What do you mean by circular reasoning with the reversals of the magnetic field? I'd like to hear from Sam.
No, it has reversed. Even young Earth creationists have admitted it reversed.
So what's your circular reasoning then? Where you said circular reasoning?
Are you saying that this is over millions of years that the magnetic field has changed? Because that's what you're trying to prove. That's circular reasoning.
All I said is it's changed dozens of times. I never said over millions of years. All I said is dozens of times. And you can
even young Earth creationists have admitted it was stronger in the past, and they have admitted that the intensity in certain directions has changed.
Okay, here's where I want to jump in and say something, please, because this is what I'm seeing. There's an assumption going on, and so of connecting the magnetic reversals with the decaying magnetic field. They may be connected, but we don't know that they're connected. So the decaying magnetic field is something that we're observing, and we've never observed anything else except the decaying magnetic field. Now, we know there were reversals in the past, but it's an assumption to connect those together and say the reversal is what causes the decaying magnetic field to be renewed. And I'm not a geophysicist and I know nothing about this. But when I did talk to a physicist who has looked into this, he said, we actually have no idea where the magnetic field, how it would be able to be renewed, because it would need some sort of dynamo in the core, and we don't know where to get that. So the where the magnetic field has been able to, if it has, survived for so long, that is, we're assuming that it can because we're here and we have a magnetic field. No, but we don't actually know.
I'd like to respond to that. First of all, that's not true. We can observe from the rocks that the magnetic field has decayed, reversed, and strengthened. And it's done this, I'm looking at the chart now, I don't know, 100, 200 times that we know of, at least. And so we know this happens. That doesn't mean that we have a mechanism to explain it. And the lack of an explanation doesn't mean it can't happen. We know this has happened by looking at successive lava flows. We know.
Ask a question on that.
Yes, ask.
Oh, I interrupted you, Dr. Howard. So
that's okay. That's okay.
I consider it rude when I do that to people. I'd like you to complete your thought, but I just wanted to.
Yeah. So we know that the magnetic field has decayed and then reversed and strengthened before, and this has happened, I don't know, 100, 200 times. And so you're right. We cannot positively connect it to this, but we can say that this is a pattern that has occurred so many times in the past. It would be, it would violate Occam's razor to say this is some special set of circumstances. We know this has happened many times in the past. And the fact that we don't have a mechanism to explain how the dynamo happens doesn't mean it doesn't happen. It just means we don't yet understand it.
I need to ask a clarifying question though, because what my understanding, and I want you to correct me if I'm wrong, is that those reversals is showing a reverse in the polarity of the magnetic field, but not necessarily the strength of the magnetic field. Is
That's
that
not true. That's
okay?
Not only does it reverse in polarity, but there's actually something called polar wandering curves. So when you measure the magnetic field in a piece of lava, they collect the piece very carefully. Not They orient it due to the true north today, so we can know what direction it is. So we not only know that the orientation has switched from north to south, but also which direction is magnetic north has changed gradually. And when we look at the different continents and line up the radiometric ages, which you don't believe in, so it's just an amazing coincidence that when you look at the radiometric ages for lavas in different continents, they point to the same direction that all the continents have moved through time. And so that's how, when you go back in time, it's not just that the Atlantic used to be closed. The Atlantic was closed, then opened, then closed, and opened several times. And so, we've got lots and lots of evidence from paleomag studies that show how the continents have moved through time. So it's not just whether it's pointing north or south, but in some cases, the magnetic field points due east, and because the continent has rotated. And when you measure successive lavas through time, you can see the gradual transition as the continent rotates. I want to also make just one point about erosion. A lot of creationists talk about erosion. There is no evidence from erosion that the continents wouldn't fit together, that mountains wouldn't exist. Certainly, there have been many, many cycles of mountains growing and being eroded to nothing, and then new mountains growing and being eroded to nothing. So this has happened many times. The fact that mountains exist, the fact that the continents fit together is not a problem for an ancient Earth. So I just want to go back to that point because I was thinking about it.
Okay, before I ask Dr. Howard the question I had, and it's not a gotcha question, just to let you know.
You can ask anything.
But I wanted to say, when you said a lot of the creation stuff is, you consider it bad, I have to agree with you. So I thought that even within my own field in biology. So we're not in disagreement there. I'm actually more sympathetic to your criticisms. However, as I said, there are things that had always caused me pause in the more that I study it. So the question I had is, in the geomagnetic record that we have, do we have indications of the number of microteslas that indicate the field strength? Okay, so I just did an AI overview here, just to let you know this isn't from the top of my head. It says here the Earth's magnetic field strength across the surface on average is approximately 25 to 65 microteslas. What was the strongest field strength that we've recorded in the geomagnetic?
Okay. I'm sure it's known, but I have no idea. This is not my field. This is
okay.
A little bit about. But one of the things that creationists get wrong a lot is they think that the magnetic field reversals were determined by the measurements in the Atlantic Ocean, looking at the magnetic stripes on either side of the Atlantic Ridge. And that's an important point. That's not true. That's not where the discoveries come from. The discoveries come from looking at successive lavas on land. And what's really interesting is the reversals that were discovered by looking at successive lavas on land were well established by the mid-1950s before anybody had heard of the term plate tectonics. And so this was a prediction of plate tectonics, So what they did is they looked at the magnetic reversals, they looked at the radiometric dates, they looked at when they thought the Atlantic had opened up, and they said, well, if this is true, then there should be magnetic stripes parallel to the Atlantic Ridge. And the competing theory at the time is something you guys have never heard of called geosynclinal theory, which has now been long abandoned. The geosynclinal theory said the continents were always in the same place, and then on the mid-Atlantic Ridge, there should be no magnetic stripes. And so this was a prediction of plate tectonics, and they built the device to measure the magnetic field on either side of the Atlantic Ridge. And of course, it was true. And so that was, this is the difference between science and religion, is that science makes predictions, and they're predictions about things you don't know already. Like nobody had any idea that there should be magnetic stripes in the Atlantic Ocean. And it's not the Atlantic Ocean. Let me finish. It's not just the Atlantic Ocean, but it's all the spreading centers around the world in the Indian Ocean and other places in the Pacific. And so this has been a very powerful prediction of plate tectonics.
Okay, I would just like to say something.
By the way, I just wanted to, Dr. Howard, thank you very much for your response.
You're welcome.
Thank you. Yeah, so basically, yes, Dr. Howard, there's a lot of, I see strawmans here, maybe unintentional, I don't know. Maybe just don't know the creationist arguments on a lot of things that you're mentioning. But you said, for example, you said about plate tectonics. Well, I don't know about Sarah and Rebecca, but I do believe in plate tectonics. So how comes I'm a creationist? I believe in. Do you see how it's agnostic evidence? It's not something that plate tectonics is not like a thing. Oh yeah, absolutely, 100% proves billions of years, because it's not. It's really not. You interpret that way, that's fine. We have our model for it as well. Some people believe in the hydroplate. I personally believe in CPT. There's competing models there in creationists. And it actually fits quite well with the data that we find. Like I said before, cold slabs. Okay, fine. You said that you said something like there's no way to measure temperature, something like that. But the seismic tomography, basically, we measure the velocity, right? The velocity that the rocks are moving, and that can tells us, basically the temperature, because it makes sense, right? Basically, if it's moving fast, it's hotter. If it's moving, if it's not moving much, it's more solid. It makes sense.
The other way around. The other way around. Yeah. If it's moving fast, it's cold.
If it's moving fast, it's okay.
Cold, dense rocks have fast velocities. Warm, soft rocks have slow velocities. So you have it backwards.
Okay. Thank you for pointing that out. I'm definitely gonna have to look that up to me. But anyway, we have found through seismic tomography that there is these giant anomalies in the mantle. They are the so-called cold slabs. This doesn't fit in any way or shape or form in the old Earth model. It is not expected to have cold slabs down there.
Okay, first of all, that's not true. The thickness of oceanic crust is about 6 to 8 kilometers, and
I know that.
Rate at which the mantle moves is a few centimeters a year, maybe 2 or 3 centimeters a year. So it takes a long time for these slabs to be subducted, and it takes a long time to heat them up. And it is not straightforward at all to measure to convert velocity to temperature. That is a very difficult thing.
But you see
a lot of assumptions. But let me ask about the temperature directly. So what we observe in the Atlantic Ocean in the crust is that the crust gets colder as you go away from the Mid-Atlantic Ridge, and it's way too cold for the crust to have been created 4,000 years ago. How do you account for the temperature? This is the well-known temperature problem in creationism.
Oh, you're talking about the so-called rapid nuclear decay. I don't really oblige by the rapid nuclear decay.
I don't know what rapid nuclear decay is. I'm just talking about temperature. I'm talking about temperature.
No, I know. It's because they're talking about the heat problem and rapid nuclear decay. But yeah, I don't really hold to that view. So therefore, in my view, I wouldn't have a heat problem, about this. But basically, did you realize that you said something that is self-defeating? The slabs are moving very slowly, and it takes a very long time to heat them up. But you just said that it takes a very long time for them to subduct. So this is something that's kind of self-defeating, because it wouldn't be cold anymore given billions of years. And this is what I meant at the beginning, by you can't account for that in any deep time model.
There are papers that have done the calculations on how fast the slabs heat up, and there's no problem. And instead of just guessing, read the papers where they've done the calculations.
Oh yes, I read a few.
I've read explaining how the Atlantic crust is so cold if it's so young?
I've read a few papers where they basically did a simulation and they completely removed things like shear heating, for example, out of the simulation. So basically, anything that's gonna help it keep it colder for longer, let's remove it out of the simulation for convenience sake. So yeah, I mean, a little bit of a problem when the simulations kind of ignore physics. So, but yeah, I've definitely looked into a few papers
So
like that.
another problem for young Earth is isostatic equilibrium. So the right now there's 20 kilometers, give or take, of sedimentary strata in the Gulf of Mexico. Aside from a small area around the Mississippi River Delta, everything is at isostatic equilibrium. And yet, how did that happen? We know how fast the crust reacts. These are all things that are easy to calculate. The isostasy is due to the difference in density and weight of the crust versus the underlying mantle. We know how thick the mantle is. We know how rigid the crust is. We know how heavy the sediments are. The crust reacts at maybe 2-3 centimeters a year, and you've got 20 kilometers of isostatic equilibrium to achieve. How do you do that?
No, I understand. But you see, the maths are already assuming deep time in order to explain it. So because the Gulf of Mexico situation, like I said, that's why I really encourage you, Dr. Howard, to look at the CPT model. It's the model that I lean towards a little bit more than the other creation models, because it accounts for basically all the data, in my opinion, honestly, all the geological data that we see.
I've never seen them account for this isostatic equilibrium of the Gulf of Mexico.
It does, because
I'd like to see that math. And they also don't account for the temperature, because it takes a long time to heat those sediments up, because the heat is propagated from the mantle through the oceanic crust and then up through the stratigraphic section. And you have to get it up to about 200 degrees C in order to generate oil. And the Gulf of Mexico has generated a huge amount of oil, so we know it got hot a long time ago. And so you can't, there's no mechanism in CPT to account for that.
That tells me you haven't actually read Dr. Baumgartner's paper, because not only he's using the most sophisticated simulated program for plate tectonics, even seculars are using it. That's how good.
I've read parts of it, and it may be very sophisticated, but it violates basic geology. He just he literally just geologic data, and so I get tired of reading this stuff. I've read a ton of creationist books, and as I've said, every time I've read a creationist book that touches on a topic I know well, they are ignoring the basic geological data, and that includes Tim Clary's book. I've read that book cover to cover, and it's got dozens of false statements in it.
For example, Dr. Howard, convection, not proven, and yet it's something that I believe that you believe in.
How can convection go through impermeable rocks? That would be nice to know.
Basically, I don't hold to convection. Maybe you do, because a lot of secularists believing in convection in the mantle, where the mantle is somehow spinning and recycling new crust or whatever. To me, it's a lot of, I don't believe in that, because there's no evidence for that. Dr. Baumgartner's simulation uses, guess what? Gravity. That's what it uses. And it accounts for the separation of continents in a year in the flood model, because the mantle was heated up, and that makes so that the oceanic crust, which is more dense, is less dense than the continental crust. It's
other way around, my friend. Other way around. Oceanic crust is more dense. For someone who says they know a lot about this.
Thank you for correcting me. You're right, and that's exactly why they subduct, because they are indeed more dense. Thank you for correcting me. And basically, the more it slides down, it's gonna create more and more. It's gonna heat up the mantle more and more, and it's gonna subduct faster and faster. This is a simulation based on gravity and just basic physics, basically, that Baumgartner used.
But he doesn't account, for example, the many generations of mountains in North America that have been created and eroded.
Absolutely does. Uplifting. Oh, absolutely. Yes.
Not just uplifting, but uplifting and eroding, and the granite batholiths that have been created in the middle of the mountains and are now today.
Oh yes. Yeah.
How did they cool down? How did they cool down?
because as new crust is being created by the ridges, right? Basically it's gonna flood the earth slowly but surely. It's gonna flood the entire earth. His simulation found that because you're creating new crust, and it's gonna make the waters rise higher and higher, basically. And that's going to deposit sediments. It's going to deposit sediments in the continents. There will be depositions there. And once the flood waters are receding back, once you have the uplifting and the flood waters are receding back to the lowest point, which is going to be the new ocean, basically, after the flood, that's, they're still hardening, right? They're still hardening. Of course, they're going to erode like the Grand Canyon. They're still hardening. And Dr. Howard, that's exactly why the layers are flat. That's why you don't see bioturbation in the layers. There's no evidence that each layer.
Okay, let's talk about that. Let's talk about
There's no bioturbation there.
Let me respond to that one point. So bioturbation is pervasive in almost all deposits of shale. It is very hard to find shale that is not bioturbated. And this is something that creationists get wrong continuously. I've seen bioturbation. Do a Google. Do you know what Google Scholar is? Yeah. So go type in Google Scholar. Type in any time period you want after about the Ordovician, but type in Cretaceous bioturbation. You'll probably get 5,000 to 6,000 citations describing bioturbation in the Cretaceous. And then do it.
Okay. Evolutionary papers.
Let me finish. Bioturbation is pervasive. It is not rare. It is abundant. It is far too abundant for a young Earth.
I know, and that's exactly why the fact that there's no bioturbation in the layers.
I just said that's not true. The most layers are pervasively bioturbated. It's hard to find a layer of shale that isn't bioturbated. Okay. Go out and look at the rocks. Don't just believe me. Go out and look at the rocks.
Okay, so basically,
bioturbation is pervasive, and this argues against. Pervasive means common.
I know.
But you just keep saying it's not. It's not.
I know
true.
it's common on the top surface. I understand that.
No, it is common throughout. It's common. Not. Yes, it is. Yes, it is. Oh my gosh! Go out and look at the rocks.
Go out and look at the Grand Canyon. Great example right there.
Well, you have to look at the Grand Canyon. I haven't been to the Grand Canyon. I'm a geologist, but I haven't been there. But if you look at, say, the Mancos Shale, which is a Cretaceous shale that's well exposed in Utah and western Colorado.
By the way, fossils are not bioturbation. I know we find a lot of fossils, but that doesn't mean bioturbation.
There are tons of studies that show that it is thoroughly bioturbated.
What you failing to realize,
bioturbation is so much that the young Earth cannot be true.
What you failing to realize, Dr. Howard? See, people believe in billions of years and they can't even comprehend it. Dr. Howard, given billions of years, how much bioturbation should each layer have? And we don't find that common.
That's not
true. They should be everywhere. They should be everywhere.
It is.
It's not. It's not.
It is.
It's not.
Well, let's compare our experience. Where have you been out in the field where you have looked at rocks and looked for bioturbation?
Okay.
Where? I'm asking you where.
No, I know. Basically, all I'm saying is from everywhere that I've seen, from all the,
where have you seen?
I have. Okay, look, I haven't been many places. I agree. You've probably been way more places than I have. Okay. However, it's just known that it's a known fact that it isn't there. You might be talking about fossilized.
This is another creationist myth. That bioturbation is pervasive in many places, way too much for a young Earth. And when people say it's not, that means they haven't looked at the rocks. And I know that Kurt Wise says that most shales are laminated. That's a lie. Vast majority of shales are bioturbated. This is based on my personal experience. I've looked at vast amounts of shale, and it's just pervasively bioturbated. Not everywhere. There are shales that aren't bioturbated, like the Green River Formation, because that's fresh water. You don't get
Yeah.
bioaccumulation
Okay.
in
So
water. But
another
marine shales, it's really rare to see a marine shale that is not bioturbated.
okay.
So before I joined an oil company, let me finish. Before I joined an oil company, one of the things I had was a masonry saw. And so masonry saws, use it to cut like cement sidewalks. It's a circular saw that has an ablation blade with a engine like a chainsaw. And if you want to see what shale really looks like, you got to buy a masonry saw, cut out a block of shale and put a plaster coat on it, and then polish one side, and you'll see the bioturbation. It is pervasive. It is really hard to find marine shale that is not bioturbated. Sandstones sometimes are bioturbated, sometimes they're not. It's just so common, and for creationists to say it's not just defies logic. I just don't understand how you can
okay.
how you can say that, and when there's so much evidence that it's not true.
Okay. That's why it's hard to comprehend just how much and how common it should be given the billions of years.
It's very
And
common.
again,
So here's a question: if the Precambrian is pre-flood, that would have been deposited slowly, so that should be thoroughly bioturbated. And the flood sediments should have no bioturbation, but it's exactly the opposite. There's almost no bioturbation in the Precambrian, and yet the Phanerozoic and the Phanerozoic is almost completely bioturbated in the shales, in the marine shales. And so the pattern of bioturbation is exactly the opposite of what you would expect from a flood model.
yeah. So basically, yeah, that's the claim that you make in there. I understand.
I'm not making a claim. That's evidence. This is stuff you can go out and see. This is not a claim. This is evidence.
Okay, doctor. Okay, I will definitely look into that. But once again, I'll cite two problems for you. Since you love the geology side of things, I'll cite two problems for you. First problem, we find the trilobite tracks going through multiple layers, which, well, yeah, it's a kind of a issue, but
That's why is that an issue?
Yeah, I mean,
Why
yeah,
is that an
and
issue?
exactly. And that's why when you look at the Grand Canyon and you look at the layers deposited on top of the the Tapir sandstone, you find the trilobites going through multiple layers of multiple layers of sediments. That suggests that each layer, well, not really a long time, is it? If the trilobite is going up that quickly like that, that's one problem. I'm gonna cite another problem for you, and you can respond both to them after I'm finished telling the problems. Second problem for you. Dr. Andrew Snelling went to the Tapir sandstone, which is basically the first layer, right, of the Grand Canyon. And we have folds. I'm sure you're aware that we have folds in there where the layers are bent, or the Tapir sandstone. Okay, fair enough. You might say that the layers have undergone a metamorphosis event. You may say that that's why they bent. I mean, if you believe in billions of years, you kind of have to do that, right? Because, to explain why is it bent? Why is it bent? Even though it's the layer up below the Grand Canyon where everything is flat, so why is it appear bent? So you have to assume you underwent metamorphosis. However, he took rock samples. He took rock samples out of the Tapir sandstone and went into a lab to look at it. And he found. I'm gonna give you the link to that paper after.
I know what you're talking about. I know the paper.
Yeah, and yeah, exactly. And he found that there is no evidence that the Tapir sandstone underwent metamorphosis because it's still very clastic. It's still very sedimentary. There's no evidence that the minerals in there actually all squished like metamorphosis. So basically that's consistent with rapid deposition. Interesting. The entire Grand Canyon being rapidly deposited, because how can the Tapir sandstone bend after millions of years of the Grand Canyon slowly forming on top of it? It doesn't make any sense. So now we know it has not underwent metamorphosis. Therefore, the entire event, the Tapir sandstone and all the layers above it, had to be quickly and catastrophically. This to me is pretty good evidence, Dr. Howard, for the flood. But anyway, go ahead.
All right. So first, about the type of burrows you're talking about are escape burrows. They're very well known. So all the evidence that creationists cite for rapid deposition is all entirely true. Here's what they're not telling you. all of those different kinds of evidence were first discovered by mainstream geologists, completely incorporated into mainstream geologic theory decades ago.
That's not
And
true.
then the creationists like to pretend that they're discovering something new. So all the evidence for rapid deposition that creationists like to cite, there's one example I think I know of that isn't true, but almost all of them are true. But they're all old. They're all old. These are, by old, I mean they've been known for decades.
No.
Let me finish. I didn't interrupt you, so it's now your turn not to interrupt me.
Sorry. Go ahead.
So all those evidences of rapid deposition are absolutely true, but they're interspersed with episodes of very slow deposition, with intense bioturbation, with rooting, with paleosol development, with erosions and scours. And so what the creationists do is they like to cite all the evidence of rapid deposition and then pretend that the evidence for slow deposition doesn't exist. But they both exist. So the evidence that geologists have seen for decades is that deposition is episodic, not continuously rapid.
Okay.
And yeah.
So doctor, that's not true because Dr. Snelly specifically says that he looked at the literature. He didn't find anything on the Tapir sandstone.
Well, I don't know. Like I said, I haven't been to the Grand Canyon. I don't know what specifically.
So he was quite literally the first one to actually undergo this study, this proper study of looking at the actual composition.
Well, this has been looked at many times. The mechanisms of folding of rocks is well understood. If you do it slowly under enough heat, not enough heat to actually metamorphose the rocks, but just enough heat that you can fold them slowly. And there's a lot of folds that have cracks in them where we see the rocks have cracked. And so there's really no inconsistency.
But it hasn't. That's the whole point, doctor. It has not been metamorphosed based on empirical observable evidence. It has not been metamorphosed.
I just said it can be done with heat, but not enough heat to metamorphose it. But going back to the soft sediment, there's so much evidence that folded limestone, for example, was solid before it was folded. For example, there are shells that have within them sediment at the bottom part, and it's been fully cemented, and then the shell is rotated so you can see what original horizontal was, and it had to have been rock before that happened. We also see lots and lots of evidence where chunks of rock have been eroded from underlying layers and then incorporated into the overlying layers. I've seen that myself. And so we know these sediments were solid rock before they were eroded and while they were being bent. And so there's no inconsistency. You're ignoring a lot of data to get your fit.
Doctor, I'm going to ask you a question.
Sure.
Okay, think with me. You believe that the Tapir sandstone came first, right? And then the other layers on top of it, of the Grand Canyon, came after through millions of years and so on. Okay. And then you're saying that somehow slowly metamorphosed, just enough heat, bent the Tapir sandstone. We have found evidence that this didn't happen, okay? And metamorphosis, you are well aware that has to happen at a temperature. It has to be underneath the ground for it to happen and then be uplifted. You're not gonna get that temperature somehow in the surface. But now we know this bend happened in the surface because there's no proof of metamorphosis. So you can't just invoke slow metamorphosis, just enough heat. No, because
I have said like 5 times that you can do this by heating the rocks without enough heat to cause metamorphism. I've said this so many times, and you keep
metamorphosis happen at about, I would say, 100-ish C or something like that.
No, not even close.
Okay, yeah, okay.
Oil is generated at 200 C, and that's not metamorphosis.
Exactly. You're not gonna bend rock with the amount of heat that you're saying. Oh, just about heat, just enough heat, a little bit here, a little bit there.
How do you know that?
How much heat? Okay, metamorphosis in order to melt rocks require a lot of heat, like you said, right?
You don't need to melt it. Nobody's saying you melted it. My goodness.
Okay, wait. So how did the Tapir sandstone bend then? How did it bend?
Well, first of all, I don't know anything about that one example. There are all sorts of ways that rocks can be folded while they're soft before the next layer is deposited, such as slumps. So slumps happen in the modern day, slumps happen in the ancient. We see them all the time.
Yeah,
And
okay,
so,
and it's gonna bend exactly the way that we find those ginormous
yeah,
bends that we find is gonna do that. Okay,
yeah,
so
yeah.
so heat is not gonna do the slumps.
You don't,
Is
I'm
gonna
saying you don't need it. I don't know that specific example, so I can't comment on it. I've never been to the Grand Canyon since I was a
there's
little kid, and I've certainly never seen those layers.
there's a
Um,
reason why you see there's a reason why everyone says that metamorphosis is what happened. It's because it's the only mechanism to save the billions of years. That's why the
it isn't. It isn't.
uniformitarianism.
That's just something you're making up. You have no evidence to back that up.
Well,
I
that's
mean, that's just what
absolutely.
you think, but that's you don't need metamorphism to explain how rocks get folded. You just don't. I mean, if it happens slowly under enough heat to get them to where they can bend very gradually, but that's not enough heat to cause metamorphosis.
You do realize that would change the minerals, right? Even if
No,
you
not
slowly, that would
necessarily.
change the
Not
minerals.
necessarily. Depends on
That
the
would change.
temperature.
No, no,
It
that
depends on the
how?
temperature.
Okay, Dr. Snelling found that there was still sharp minerals in there. Given
Okay.
the slow heat, the little bit of heat here and there, it would change and it would make them smooth. You would make them
Well, I
smooth. But
can't.
that's what heat does. That's what heat does.
No,
And that's not
no.
what he found.
Yeah,
I
Tom would like a new subject, and so would
Yeah,
I, because we've been back and forth on
I
this.
Sorry, Rebecca. No, sorry.
haven't been to that outcrop, so I'm not going to comment on it anymore.
Sorry, Sal. I know I really want Sal to speak as well, but I agree with Sal. Dr. Howard, please, don't just be stuck in your geology bubble. You need to look at the other sides for you to see.
Okay, I'll do that. Are you going to look up bioturbation and tell me how the pervasive bioturbation is consistent with the young Earth?
No, doctor, because all of this all of this is agnostic evidence that we can both account for, and actually the young Earth accounts for better. But that's the whole entire
Well,
thing.
you've said several things that are false. You said there's not enough bioturbation when there's lots of bioturbation.
Well, I think this is a good, look, I love this discussion because we actually have someone who knows his subject. And so this is good because this is a good way to find out, right? If the things that we're taking in are really standing up to, are they standing the test? And some of them might be, but we have to go back. So I'll go back and look at the bioturbation. And in fact, Howard has invited me to go with him, and he's going to show me some of the stuff. We're meeting in a few weeks to go out and look at some different formations in Utah. So thank you very much.
Lots of bioturbation, lots and lots.
So, but I think this is great. I love this kind of discussion where we have people who have expertise in an area. And so, thank you guys for sharing your ideas. I want to hear and I just want to say, first of all, yes, I'm a young Earth creationist and I want to talk about these topics, but don't forget that this is supposed to be about people showing evidence for evolution. And look, I want Howard on here. So please, Dr. Howard, thank you for being here. But every time evidence gets shared it's always against young Earth creation. There's like so little evidence that has been shared for evolution. And I think there's a good reason for that. It's because the evidence is so weak, it's so lacking, and we can just go subject by subject and show the evidence against evolution. Where's the thing coming from? Is that Junior? Okay. So anyway, but do we want to move to a slightly different subject? Sal, did you want to say something? I feel like you should jump in and say some of this, you had some things to say in the chat based on what we were talking about earlier. Well, never mind. If you have something to say, go for it.
I'm happy to refute any claim about a young Earth that deals with stratigraphy. Anything.
Cool.
Sal is muted.
Sal, you're muted.
Help. Help. Oh, am I unmuted?
Yes, you're good
I
now.
was having a technical problem. Dr. Howard, I have to say I'm very impressed with what you said. And Junior, I'm really sorry to say this, but I feel really embarrassed how you defended my viewpoint. This I don't. I just for the record, I don't get along well with the Creation Research Society. I published something through Oxford University Press, and they said, "Well, no, sorry, we're not going to accept you presenting on this." I'm the only creationist that had published at that level, and they wouldn't. So I'm just like tired of what's going on. So if you sense that I quietly agree with you on a lot of things, that's one example. Junior talked about catastrophic plate tectonics. A lot of creationists do not like catastrophic plate tectonics. And so a lot of the things you said, I'm trying to teach young earth creationism and intelligent design to creationists. I would welcome them hearing your side of the argument. They need to be equipped because they're going to get slaughtered out there when they go to academia if they think this is going to be an easy ride. And it's just not right. And it represents my cause and what I believe poorly. That being, I train people in intelligent design. I have college students going through secular schools as high as Yale. I had people had watched my blog, and now they're CEOs of biotech companies or professors at university. And I could say the community of young Earth creation is very insular. The ID community comes from a different mold because most of them come through secular schools and teach at secular schools. There's two separate cultures. And so everything you've said, as painful as this is for me to watch, I think this would be a good thing to show young Earth creationists who are debating what's going on. They need to hear what you have to say. So I just wanted to say thank you for appearing. And how do I teach ID? Most of the ID that I teach comes from secular literature. I don't quote, I try to avoid quoting any creationist or known ID proponent. And it makes it very feasible for me then to publish in secular literature, go to secular conferences. Young Earth creationism does not have that privilege. So if you see me kind of walking the line, I just wanted to let you know where I'm coming from. And as painful as this was for me to listen to you, I had to respect what you had to say, and it's so valuable. I would love to share it with my
When you say you, are you talking to me or Junior?
I'm talking to you, Dr. Howard, how much I appreciate what you're doing.
Okay.
And Junior is spouting off a lot of stuff that's at the ICR and answers in Genesis. Until we have mainstream secular stuff starting to contribute and start discussing these things, it's going to be a lot harder to move. It's been a lot easier in the intelligent design movement because, and I got a quote for you, Rebecca, evolutionary biologist Brett Weinstein says, modern Darwinism is broken. My colleagues are lying to themselves. He said this on the Joe Rogan Experience. That's an evolutionary biologist. It turns out Jonathan McClatchy is an PhD level evolutionary biologist. He is with the Discovery Institute. He's promoting intelligent design. We have Richard Sternberg, PhD, evolutionary biologist, systems biologist. He broke ranks. We have Gunter Beckley. I don't know any mathematician that said, hey, I'm going to stop believing in the axioms of the real number system, or chemists rejecting chemistry, basic chemistry. We're having more and more evolutionary biologists, either publicly or behind the scenes, coming forward. And I didn't know Jonathan McClatchy was an evolutionary biologist. I personally know 6 evolutionary biologists or professors who've taught evolutionary biology that are on our side of the aisle, Rebecca.
Really?
Yeah.
6?
I know
Nice.
6 personally. Okay. The ones that are publicly known, okay, those are privately known. The ones publicly known are John Elquist, who used to be on the other side. Now he's a young earth creationist, evolutionary biologist turned young earth creationist. I know several young earth creationists who are evolutionary biologists. There is someone who we don't know whether he's a young earth creationist or not, but Richard Buggs, Jerry Coyne called him the creationist professor. And then Of course, we know Kurt Wise, and he is a young Earth creationist. He'd studied under Stephen Jay Gould. He was considered brilliant, and notwithstanding the concerns Dr. Howard pointed about Kurt Wise's geology.
I've watched several of his videos on geology. Almost everything he says on geology is wrong. He's for someone who's brilliant, he gets an awful lot wrong. So I can't comment on the stuff he says in biology because I'm not a biologist. But when he talks about stratigraphy, sedimentology, I mean, seriously, it's hard to find a statement that he makes that is actually true.
I appreciate hearing that. So, so what? This is for Rebecca. What Brett Weinstein said, and so 20 years ago, the intelligent design movement was really being resisted. It's still being resisted, but I'm finding a lot of academics flipping quietly, and then sometimes not so quietly. Richard Sternberg was really out there, but then more recently, the late Gunter Beckley. But there are more of them. I'm aware of all these private conferences where they're just kind of fessing up to each other and then sometimes to us. And I don't think it's going to stop because the thing that has changed is we have so much data now, especially seeing how Darwinian evolution is not working. So the most famous evolutionary biologist, in my opinion, who has the highest index, Eugene Koonin, said modern synthesis, aka neo-Darwinism, is gone. And so I'm seeing all these fights even among evolutionary biologists. They're not unified, they're fractured, and they're bickering against each other because their stuff doesn't work. And then
I've noticed that you haven't mentioned anyone who's a paleontologist.
Beckley was a paleontologist, evolutionary. I'm very sorry if I'm conflating the two. My apologies.
The paleontological record is solidly on the side of evolution, and even if we don't, the paleontological record is solidly for evolution, even if we don't understand the mechanisms. Creationists, there's one thing they get wrong all the time. They equate a lack of evidence with negative evidence. And even if Darwinian evolution isn't true, that doesn't mean evolution isn't true. There might be another mechanism we haven't yet discovered. And so the same thing with the magnetic field. Yeah, we don't understand how it works. That doesn't mean it doesn't work. It just means we haven't yet discovered it.
Go.
Go.
Well, I wanted to respond to that too, but go ahead. I think.
Okay, I'll see if I do this in 20 seconds. We have a lot of people like Michael Behe who believe in common descent and would be called a theistic evolutionist, but they believe in intelligent design as well. And so Rebecca and I have had a conversation about, should we use the word progression, because we do see a progression of forms from simple to more complex.
And I don't like that, the way that Sal says that, because it sounds evolutionary. But I totally disagree that the fossil record is on the side of evolution. Now, I do agree that there are some problems for the young Earth side in the fossil record, but I think there's many more problems for the evolution side. And now I hear your point that you're saying that, just lacking evidence for, is not necessarily negative. But how can we, then can we just look at the observations? If we just look at what we see in the fossil record, do we see a progression from, of transitional forms? No, we don't. We see sudden appearances, another sudden appearance, another sudden appearance, another sudden appearance. So that's what we see. So then if that's what we see, then shouldn't we accept that what we have is sudden appearances, rather than pushing a narrative that things developed slowly over time? If that's what we see, if we see things developing slowly over time and millions of transitional forms leading up to these, various forms, then we could say that we have evidence for evolution in the fossil record. Right now, we can say we don't have evidence for evolution in the fossil record. You can maybe point out one or two you know, maybe you could get like 10 transitional forms possibly, but if evolution is true, we should have millions. Like there should be more transitionals than the forms that are, you know, fully formed as we see. Go ahead, Sal.
I'm sorry to be insistent on this, but remember that quote I keep quoting? And by the way, I shared this with when I spoke at the Discovery Institute. Dr. Dan said, there is no common ancestor for all proteins. And I was speaking before crowds, you know, a group of professional protein biologists, biochemists, microbiologists, molecular biologists, biophysicists. They all kind of smirked. And then I said, but Dr. Dan thinks it's no problem since new proteins arise all the time. And they all gave me that look when I was speaking. So as far as the fossil record, we do see some slight staircase progression, but where it is really difficult is not in the fossil record. That's the transition from prokaryotes to eukaryotes. And we've had a molecular biologist on this program, Change Tan, who was appointed by Nobel Prize winner George Smith to teach molecular biology. She was not a creationist. She was not an ID proponent. She came from atheistic communist China. When she started teaching molecular biology, she's teaching on eukaryotes and prokaryotes. She realized this had to be created. That was the end of her being an evolutionist. This is a transition that doesn't make sense from the molecular side. And on the protein biology side, we have metazoans that need collagen. And collagen just sort of pops up in kind of the bioinformatics. It's like, where did that come from? It doesn't have any ancestor. It's just like, well, Dr. Dan said, no, all major protein families do not have a common ancestor. So you don't have transitionals. That is already acknowledged. When you quietly talk to people who actually understand kind of evolution at the molecular level, particularly protein biology, you have no transitionals. So even though we can kind of concoct these so-called transitionals from the fossil record, from, you know, like a single cellular thing to something like a multicellular animal, you have all these gigantic leaps that would have to happen in terms of the proteins. And I was just sharing this with an intern that was working with me, and she said, yeah, that's kind of difficult. These are transitions which the fossil record doesn't explain. You cannot extrapolate, no matter how hard you try, to take bones and then try to explain what happens at the molecular and protein level. So as far as, you know, maybe evolution over time, I would say Michael Behe. He believes in common descent. I disagree with that view, but I'm more closer aligned to Michael Behe than a naturalistic evolutionist. And that's kind of the thread that has been going through ID. It's like where you have creationists and people like Michael Behe, we can have a lot of agreement together, but we won't agree on the other things like young Earth, etc.
Well, first of all, there are lots of transitions. The problem with finding transitions is you have to look at fossils that occur in huge numbers, because vertebrates, you just don't get the numbers to find the transitions. But if you look at microfossils, there are dozens and dozens of examples of transitions. I mean, you can't even document all of them. They're so common.
Well, I'm sorry, I interrupted you. My apologies. Go ahead, Doctor.
Yeah, so there's lots and lots of examples of transitions, and there's a few examples from the vertebrate world. I think the transitions from the therapsids to the mammals is well documented, and there's a few other transitions that are, they're so finely divided that if you put the fossils in a row, you wouldn't be able to tell where the boundary is. So there are transitions. There aren't a lot, and there's a lot of animal groups that appear suddenly. But usually when creationists talk about animals, they're only talking about vertebrates, and there's a huge plethora of examples from invertebrates and from microfossils.
What I have tried to tell creationists is stop arguing over the fossil record, because your most what they call discontinuities, where there cannot even be transitionals in principle, are at the molecular level, and that is between the prokaryotes and eukaryotes, but then also with the major protein families that appear, like say, only in the metazoans. I mean, without 30% of our protein weight, of our proteins by weight are collagens. It may look trivial if you look at it in a superficial level, but the collagen is a very complex system, and it doesn't really have much of a homologue anywhere else. And then we have other classes of proteins that are unique to eukaryotes and then eukaryotic animals. There's not even a transitional in principle when we go through. I can show.
There's not a transition that we know of.
No, it's not in principle, and I could show you a diagram of exactly this. And finally, Dr. Dan had to concede, and I'll show you the diagram. And you can see it. It's the protein sequence. It's just one diagram, Rebecca. Go on.
No, I'm laughing, Sal, because it's like Dr. Dan. I mean, how many times, like, it never fails. You've never let him live down this protein comment that he made. Every single time I ever see you on anything, you always mention Dr. Dan said there's no common ancestor to proteins.
Okay, I'm going to show it to you right here. This is the explanation why there's no transitional. So on the left, you have collagen. It's about 1,500 amino acids. You can use English alphabetic letters to represent the amino acids. And on the right is a zinc finger protein, about 500 amino acids. So on the left, I've highlighted the G, the glycine residues. So you can see every third G is a glycine. That's the reason it's periodic like that is it enables the collagen to have a particular helix, what they call a collagen helix. So that facilitates the winding. The parts that are not highlighted with those red bars have special functions that are, it's actually clipped off in what they call post-translational editing. That's not that important. The important point is you compare that to the human zinc finger there, where I've highlighted the various columns. Now, the important columns would be the ones in red where they are H's. Those are cysteines, and then the H's in purple. I don't know if you could see my pointer, the purple. So I said, look, Dr. Dan, do you think this had a common ancestor? He said, no.
That's his opinion. That's not evidence. That's an opinion.
How can you? Well, the problem is, how are you going to prove this came from a common ancestor of a gene locus?
All you have to do is show me evidence that it cannot possibly have happened. You have to evaluate every possible combination of amino acids that could have evolved into these proteins and show that not a single combination is possible. And that's obviously an impossible task. So the best evidence you have is somebody's opinion.
That's not, okay, when you've asked enough, I've asked enough evolutionary biologists, they agree with me. There's no common. I presented this at Evolution 20.
Opinions is still opinions. It doesn't matter if you have 100 or if you have 1,000.
This is evidence they don't have a common ancestor. You're saying there's no truth. You can't find it for it. I'm sorry.
But hold on. Look, if someone says we have shared ancestry, we have common ancestor, it's not up to the person who doesn't agree to prove all of the possible, like to rule out all the possible scenarios. Is the person who says they do have a common ancestor that has to show evidence for a common ancestor. So it's not Sal's job to go and look at millions or billions of possible scenarios and find out that they're all wrong. Like, there's no reason to believe it in the first place.
I think that's exactly what he has to do. I have no idea if there's a common ancestor or not, but that's not evidence. That's just my opinion. And when you say somebody doesn't think there's a common ancestor, that's their opinion. The onus is on you to prove that they cannot have a common ancestor. It's not on me, because there's enough evidence for other things having common ancestors.
You were claiming there are all these transitionals. There are no transition. Okay, so let me just say this.
Well, proteins don't get preserved, so of course we don't see. Nobody sees the proteins from the Cambrian, so we don't know what those proteins look like.
But there aren't people that believe that a zinc finger and a collagen have a common ancestor from the same gene locus. It's like, where did they come from? The other thing is a gradual transition is not feasible, especially for like the zinc finger, because a partially formed zinc finger won't work. This is like critical parts of a car.
Okay, but that's what people. Okay, let me respond to that, because that's something that people get wrong all the time. That's like saying half an eye won't work. And so therefore the eye had to evolve suddenly or appear suddenly. The thing is, it may not have worked for that function that you're talking about, but it could have worked for some other function that you don't know about. And so we see this, I'll use the example of the hand. So, the evolution sequence shows that it was first a fin, and then it was a foot, and then it was a hand. So it's not that it had to evolve into the function of a hand in one step. It evolved through a series of steps that had independent and different functions, and at every stage along the way, it had a useful function. And so when you say a protein wouldn't have had this function if it didn't have that part, well, it could have had some other function, and you don't know that.
No, well, we have a lot more data on proteins and how they work. This is not like a fully formed organism. Some of these sequences are so specific that if you knock out a few letters, it's just as good as dead. The reason I know that on certain proteins, like the topoisomerase 2 alpha protein that I published on, is it is a target of chemotherapies. We know how to disrupt it. It's like, okay, if you've seen the complexity of this, you know that it doesn't form. In fact, we have posed that to evolutionary biologists and say, look, where's the transitional from whatever its ancestor is? Dead silence. And then I pose
this is going back. But this is going back.
If I may finish my point, sir, if I may finish my point. The thing is I start presenting diagrams like this. They start agreeing with me. I'm pointing out they agree with me. So I'm in the majority opinion here, along with evolutionary biologists, that these don't have common ancestors. From, they'll say, well, the cell had, we had some LUCA that was a common ancestor for all of the cells. I'm like, okay, I'll grant that for the sake of argument. But you can't say that these have a transitional from anything except some random gene locus. You have no idea where it came from and how it evolved. We are actually on agreement. You're in the minority by coming up with these speculations. And this is also out of your field.
It is out of my field, but I'm not speculating. I'm saying lack of evidence isn't negative evidence. If you don't know how it happened, that doesn't mean it can't have happened. And that's all you're saying.
It's not absence of evidence here. It is a matter of the complexity of proteins. We know how difficult, we have some idea of how difficult it is to make these things and what will break them. It is far easier to break these than to make these. These are the most sophisticated machines that we can't even make them if we tried from scratch. That's how sophisticated they are. They're small, and they're very well integrated. And if you take away the pieces, they just don't work. We know that as a fact. That's why we know that there aren't transitionals.
So you have taken away every single amino acid one at a time to prove that it doesn't have that function and doesn't have any other function.
Other people have, and you can
every single amino acid in that.
Not every single amino acid. We know where the critical parts are. And so if those critical parts are missing, it's dead. On a topoisomerase, I could show you I have a colleague that knows where the metal binding sites are. If it's gone and it's just one or two amino acids, the whole thing's gone. One amino acid. And then there's the ATPase binding domains. These are like passwords. These are critical parts. And so, that's the problem is you're speculating outside of your realm of expertise, sir.
I'm not speculating. All I'm saying
I'm telling you, it is improbable. It's substantially improbable. People know.
Exactly right. Improbable. Not impossible. Improbable.
Well, the weight of evidence is on my side.
I'll take you at your word. You said improbable. I'll take you at improbable.
Okay.
So give me 100 million years and we can do it.
Actually, that doesn't work either. Exactly for the.
You said improbable.
That's more opportunities for things to go wrong, especially for the eukaryote prokaryote transition, where you need maybe 300 proteins simultaneously to appear to make that possible. You only get one shot, because if the nuclear localization and transport systems are dead, the whole thing's dead. You don't have a million years. Once something is dead, it doesn't evolve.
You said improbable.
You're talking outside of your field of expertise.
You said improbable. Are you backing down from that word?
Okay, can I?
I gotta go. I'm done. So
okay,
Doctor. No, hold on, Doctor Howard. I really please don't take anything personal. I love that we had the discussion. I really respect you as a person, Doctor. You told me some things that I will search. I will research. You taught me some things today that I will research. But please, Dr. Howard, I just I want you to see that we have a point as well. Just so you don't take things to the ego side, to the personal side, that you actually will be open, to look at this evidence and to think with logic, think with logic and reason. So I just that's all I have to say.
All right, so I'll tell you my point of view. I do not care what the age of the Earth is. I really don't. I do not care what the age of the Earth is in the same way I don't care what the mass of an electron is or the distance to the sun. I just don't care. But I care passionately that we follow the evidence to the end. And the
Exactly.
evidence that I have seen from geology is absolutely incompatible with a young Earth, and it is only compatible with an old Earth. If you look at, say, the temperature of the Gulf of Mexico, the temperature profile fits exactly what we would expect if the Gulf of Mexico is 150 million years old. And yet it would have to be some amazing set of coincidences for it to have occurred some other way. And, I hear people that are creationists say things that I know are false, like when you said there's not very much bioturbation, when it's not true, and all sorts of other things. And so, you say, look at it passionately. Are you willing, Junior, to consider that the age of the Earth is ancient because the geologic evidence says it is? Are you willing to consider that possibility? Yes or no?
But before you just said to you, it doesn't really matter the age. I mean, I can speak for myself, but for myself, it is important, yeah, that we know that things are not deep. It's not the most important thing, mind you. God is the most important thing to
You
me.
didn't answer my question. Will you consider that the age of the Earth might be too old for biblical chronology?
I know, Doctor, but I've looked into many. I didn't look at just geology. I looked at genetics. I looked at history. By the way, history doesn't even go back more than 5,000 years.
Junior, he just wants to know if you're going to be honest about the evidence. If the evidence shows the Earth is old, would you accept the Earth being old?
I know, Rebecca, and I was just telling him that I've looked in many fields.
It's a yes/no question. Either yes you are or no you're not.
But if I'm telling you that I've looked into many things, that tells you that yes, I'm interested. That's why I said that.
I'm asking specifically about geology. If the geologic evidence shows the Earth is ancient, are you willing to consider that possibility? Yes or no?
That's illogical. I can't just look at one area.
Because I'm telling you, I am willing to consider that possibility. This is why I've bought and read so many creationist books, looking for this. I'm saying there must be something there, and yet they all are filled with misinformation. And so I am willing to consider that possibility, and you are not. So which one of us is biased?
No, Doctor, I am willing to consider that. You see, this is why let me, speculate. No, let me say things, first. I am willing to see if he's old or not, of course, because I want to follow the evidence as well.
And so if the evidence shows the Earth is far too old, say way older than 10,000 years, you'd follow that evidence.
I will follow the evidence. Yes. But I think it's illogical, Doctor, to say that geology is going to be the main factor here. I think it's. Would you agree it's illogical?
The reason I go back to geology, and I'll say this again, is every time I see a young Earth geologic argument in an area where I have expertise, that argument has been bogus. Now, it is possible that the only bogus arguments are in areas where I have expertise, but I think that's unlikely. That would be a tremendous amount of coincidence. And so the geologic arguments that Snelling makes and that others make, I mean, I watch his videos and I almost want to puke because they're just filled with false information. And so I get tired of reading, I'm just not going to buy any more of the books or read any more of his articles because the few that I've read are just so terrible. He just ignores basic evidence. So
Are you following? Are you really following the evidence, Dr. Howard? Because I've challenged you with one thing in geology today that you didn't have an answer to, and that was the Pia sandstone. You said it
well,
was slowly heating up, and I
I
told
can't
you why that doesn't
respond.
work based
I
on the
can't
evidence.
respond to an outcrop. I can't respond about data about an outcrop I've never been to. So there's plenty of folds that I've seen that are absolutely consistent with the evidence.
We
And
also have measured. We also have measured the decay rate of erosion, and if it was billions of years, Africa and South America would not have the shape look like they can fit together perfectly.
that's not true. That's just not
Well,
true.
we're
Yeah, it
getting
is
back
because we've
into
measured.
more arguments when Dr. Howard is trying to leave. So
Okay,
let's
sorry,
just
Doctor.
let
Yeah,
him
sorry.
go,
Erosion,
and we
I'll
can pick
just
it up
say,
another time.
yeah, I'll just say, I've looked at all the erosion arguments. They are not true. It wouldn't affect it. And, commonly the mistake that's being made is looking at erosion of soft sediments and then applying that to hard rock. And you can't apply it that way. So, anyways, I'm going to go to bed. So good night.
Thank
and
you.
Rebecca,
Good
I will
night.
see you in about 2 weeks.
Yep, looking forward to it.
All right.
Bye. Bye.
Okay, bye. Okay, well, it is now 9:30 for me. Are you guys tired out?
I'm tired.
A little bit.
Okay.
The night is young.
The night is young. Okay, well, we're waiting for some evidence for evolution then. I haven't heard any yet, so
Where's the evidence for evolution again?
Well, I think it'd be unsporting for me to comment about the 100 millions of years now that Dr. Howard is gone, but in the sense that it's something that people will argue. And the thing is, the genetic deterioration it's becoming evident experimentally because now we're able to sequence things. So the first thing is we know that there's rampant extinction. And so a lot of evidence for evolution ignores that but that's what they call confirmation bias and cherry picking. So you only look at the things that still remain. You forget about all the experiments of evolution that actually failed. And then within the ones that are still alive, because we have very cheap, the cost of genome sequencing has dropped by 1 million times. It's 1 million times cheaper now to sequence genes, entire genomes. So when we sequence genomes, and I talked to Dustin von Halfwegen, we had interviewed Scott Minnick a couple of years ago. His co-author, lead author, Dustin von Halfwegen, I saw him present, and he confirmed. He said, look at all the deterioration of genomes. And I asked him point blank. I said, we couldn't have made that argument years ago. He said, yeah, this is all recent. It's because we're able to sequence genes. We're seeing rapid deterioration. And I'm like, well, then, so how can hundreds of millions of years result in evolution when all observations are either extinction or genetic deterioration? This is terrible. And there is a peer-reviewed paper by Eugene Koonin that said the dominant mode of evolution is genome reduction. And he cites Darwinian processes as helping to accelerate deterioration. And then he appeals to unexplained episodes of complexification. I said, this is not a good situation for evolution. The experiments are destroying it.
And it comes back to what I said at the beginning about DNA. Codes do not build themselves. Now you can say, oh, well, but if you got you can say that's an origin of life problem, but it's not just an origin of life problem. Because let's say, you've got, let's give them the DNA code for a single, life form, like a very simple life form. Okay, fine. Now, where did all the rest of the coding come from? Because there's a lot more coding in the diversity of life on Earth, and you've got to be, and the code is so fantastic that it is able to produce the most efficient systems like photosynthesis and different things that, like, we would love to be able to do with all of our intelligence working together. We can't do something as efficient as plants do with photosynthesis. We cannot capture the sun's energy as efficiently as as plants do. So that code built itself? No. And people who say natural selection, no, I'm sorry. There's nothing in the environment that wants to build a code. Okay.
Exactly.
There's no wind, there's no rain, there's no nothing that desires to implant information in a code. That's just it's not happening. So yeah.
And I will agree with what Salt said, because in my personal opinion, I think genetics is superior in this argument versus geology. People can disagree, but I think it's superior. Why? Because if we have great arguments and great points to show that things were created recently because genetic entropy does not allow the millions of years, therefore it was created supernaturally. And why would something supernatural take millions of years to create the Earth and only then create life? That doesn't make any sense. So geology, do you see why I see geology as not really the main thing here? As even the fossil record, like Saul say, I also don't really like to use the fossil record much, because so yeah, I agree that genetics is it's like a thing above it.
Yeah. Well, it's been a great evening, guys. What? Go ahead.
Beta Sound is here.
Yes, I think he's scared to say anything.
Okay. No, I just waiting, politely waiting. That's all.
Oh, okay. So, well, I didn't want to call you out because I thought you were just doing something with your screen there. So how are you?
I am playing with my screen. I'm good. Things are going well. I have to get up at 5 a.m. and do some driving tomorrow to go to a memorial. So I can't. I shouldn't be up. I should be sleeping, but I'm not. Anyway, protein orchards. So there isn't a problem that you see. The problem that you see does not exist, because when you look way back, and we don't know a hell of a lot about this, and there's a lot of work to be done on it, but there was a cellularization event, basically, where things got encapsulated in cells, and cells started to become viable, reproducible little creatures. So we had viable first cells, right? And they had some set of proteins in them. But prior to that, there were trillions and trillions of different fragments of proteins that were created in that biological mass, right? So there was a lot of them, and they got wheedled down to the point where, and the thing is, a protein can be functional in a very short sequence with a couple of motifs. And there are, I think we've identified like 300,000 short motifs in proteins. And these things get shuffled and moved around. You got something that will handle ATP. You got something else that'll bind to some other molecule, another piece, and then you'll have another piece that turns out to be the catalytic part of it. And these are very small sequences. Now, if you modify one amino acid in any of those small sequences, yes, you're going to have a problem. But the rest of the protein is pretty pliable. I mean, there's these disordered areas. So anyway, there were a lot of proteins for the families to develop from, and we've identified, I think, 22,000 protein families, roughly. So we have 22,000 different protein families. One of them did not have to evolve from the other. There was plenty of material for all of the 22,000 to evolve from, basically.
Rebecca's smiling. She's got to say something.
What's that?
Well, 22,000 families, that's quite a lot of proteins, considering that it's highly improbable for even one protein to evolve by natural processes. So improbable that, yeah, go ahead.
Are you agreeing that they don't have a common ancestor?
Definitely not. They don't need to. And in fact, it was on my channel where Dr. Dan said that, and you first caught up and you said, "Oh my God!" But we never understood why you thought it was a problem for evolution, because it's actually how evolution works, which you've identified.
I've known that even before I presented it on the channel. The problem is when you get to a multimeric protein like topoisomerase, this is nuts. You can't
That's
just
a long ways.
That's
a
Yeah,
long
it is
ways.
long ways, and that's the point. It's not.
Yeah.
So you have
You told
polymerase.
us a story about how it happened.
But going back to this thing of a cell, if you kill a cell, there's easy ways to kill it. You just poke it and let the guts spill out, put it back in, put all the guts back in after it's dead. That would describe your scenario, and people know it's not going to come back to life. This is the Humpty Dumpty paradox.
Somebody else would eat it, and they could use those proteins.
No, if you have it in isolation, that's the Humpty Dumpty paradox. Yeah. But the thing is even if you're able to demonstrate some catalytic function of the parts, it's the integration. Because you could say, hey, I have a functioning bolt, I have a functioning nut, and I have a functioning spark plug. But you can't just, the parts have to well match. That's a problem with multimeric proteins. And
they don't work that way. They don't work that. But multimeric proteins are really common. In fact, they're more common than monomers. They stick to each other very easily. Okay, they're the dimers, trimers, tetramers. I mean, they're just prolific, right?
Well, they are prolific. They're very well designed. They're very well designed to find their matching partner in all that sea of chaos. So they stick together because it's like
they're identical. Because they're identical.
They're not all identical. You have
not all of them are.
You have heteromeric, and you have that's
heteromers have a lot of synteny between the sequences. Anyway, I don't want to get too deep into this cell, but I just wanted to tell you that we evolutionists hear you talk about protein orchards, and we're like, what in the heck are you talking about? We don't understand what your problem is because this is how evolution works.
Evolution doesn't work.
Massive amount. Okay, work. One cell.
It doesn't work in the lab. I know proteins. I know proteins better than most evolutionary biologists. I know them too. I work with protein biologists. One of them has published a Springer Nature magnum opus.
Yeah. I know proteins too, so and I've studied them in utter detail. The motifs, how they work. I know the organic chemistry behind it. I know quite a bit about how they fold and how they function, right? And I also know that they are not the kind of thing that has basically the protein space is filthy with function. There's having a functional protein. It's not as hard as you guys think it is.
All right, so
you need to look into it.
Since you want to contest me on this, at least you've been looking forward to debating me on this. So yeah. Okay, so you know that I've studied the topoisomerase 2 alpha protein, correct?
That's a pretty tough one, yeah. And I have not. I have not.
Have you studied that one?
No.
Okay. Well, then maybe you're not speaking from my perspective, obviously, of knowledge on this, because that is a homodimeric protein in eukaryotes. There is a corresponding situation with prokaryotes where it's a heterotetramer. But let's look at the homodimer. It's two proteins, and if you don't have, one part connect to the other part, it's not going to work. I have put through X-ray crystallography data to make these two things come together. And he said it's so easy to make a multimeric protein. It has. I ran this through a bioinformatic tool where you can get the all of, like, say, the ionic connections, the salt bridges, etc., that bring it together in 3D space. So out there in a cell, it's going to find its partner because it's properly shaped and we have the correct charge in the right location. And so I'd like you to explain to the audience how you think this is not a problem for it to emerge. Let me describe how the topoisomerase functions. And by the way, the Discovery Institute has published a lovely video on this with my lead author, Joe DeWeese. And I'm amazed that you aren't covering how to evolve a topoisomerase and the problem of multimeric proteins, and yet you're going to lambast me and say, we evolutionists don't know why Sal thinks this is a major problem. Just like, look, this is just one of the many of the thousands of proteins you said are in existence. This is only one. and it's
The
causing
reason-
problems, and you're avoiding it. I'm pointing out all the problems, and you just pretend they don't exist. So what does a topoisomerase do? Rebecca can tell you. It cuts. Yes. Okay, Rebecca, you go ahead.
Well, yes, I owe it all to Sal because I wouldn't know what topoisomerase was without Sal. But topoisomerase, when the DNA gets twisted up as it's being transcribed and it gets twisted up, topoisomerase comes along, snips
Cuts
it,
it.
untwists it, and slices it back together.
Yep.
That's basically it.
amazing.
Okay, so what if you had a topoisomerase that could only cut but didn't untangle, or it didn't connect? What would happen? Can you describe to the audience what would happen in that situation?
Me?
Subfunctionalization. Basically, if one quit working, then something else, another copy of it, basically would become functional for a part of it. I mean, it could happen, and you don't know. Have you looked into how a topoisomerase may have evolved?
Yes, that's another.
You want to look it up? You want to look it up?
Rebecca and I have looked it up, and Joe DeWeese and I have actually written papers on this, and it's really kind of funny what they had to say. But the problem is, you're counting on a speculation that's unproven, not by experiment. It's just in your head. Now, I have a problem with that, because if the topoisomerase cuts and it doesn't reconnect, the thing is dead as far as any creature that really needs to have its DNA entangled. And as far as we know, that's most creatures, if not all of them. And so this is kind of bad that you're having to prove your evolution and say this is no problem based on a speculation, not by actual experiment, not by actual theoretical understanding of the problems, not by calculating the probabilities. You're just kind of giving this amorphous just speculation and saying, I don't see what the problem is that Sal is pointing out. Even after he lays it all out, you just dismiss it just by, we just don't know how it happened, but it happened, and that's not really a scientific explanation. That's a faith statement. That's fine.
So
It's evolution land, Sal. Anything can happen here.
So you're relying on you're picking an example like the flagella, irreducible complexity, that one that I haven't studied, okay, a protein that I have not studied, and you're claiming that this completely proves your point, and it doesn't. And I don't want to.
I'm giving you example. I'm sorry. Apologies, Speed of Sound.
Give me one example. My bad. No, any one of the DNA repair mechanisms could be an example for you, because they're all pretty good, pretty damned. I'm sorry, I almost swore. They're all extremely hard to imagine how they evolved, right? Or to figure out how they evolved. All of them. Like, there's a lot of DNA repair mechanisms, and then the transcription factors, right? I mean, all of those things, the whole machinery involving DNA, it's all a real tough problem for evolution to figure out, okay? But there are people working on this, I'm sure, and they're figuring it out. It's just not me. So why are you talking to me about topoisomerase when I told you I don't know much about it?
Because anyway, you're saying, what's this with Sal talking about the protein orchard? I'm just giving you one example. If you can't evolve
collagen, zinc. Okay, how about zinc fingers?
If you cannot evolve one, if you cannot even evolve one, how are you going to evolve 22,000?
Let's talk about zinc.
Some of the easy ones. You can probably get these easy ones out there.
Let's talk about zinc fingers. So if we can't solve all of them, you're going to claim that evolution is false? I mean, come on.
Yes.
I mean, is that observable?
The is on you.
Is that observable?
Are you trying to give proof of evolution? So I don't look. I could give you tons more proteins. We can go over them, and you mentioned some of them. How about
zinc
eukaryotic? How about eukaryotic? How about zinc
DNA
repair mechanisms? Eukaryotic DNA, or if you want to talk zinc fingers, we can talk about transcription factor 3 alpha. That is a zinc finger protein, which they have said is very sophisticated.
Is it? There are 790, I think, zinc fingers in the human genome, and I think new ones are being created in each of us as we speak. Basically, zinc fingers. The motif is 4 amino acids. Very easy. If you randomly created 3.2 billion base pairs, you would end up with about 20,000 zinc finger motifs in that
I'm sorry
DNA
about
mess, just randomly.
I'm sorry, that's incorrect. The motif is 20. The zinc finger domain is 28 to 32 amino acids. You're off by a factor.
It requires 4 to pinch that zinc ion and turn that into a finger. Basically the finger part of it is what you're talking about, and that can be anywhere from that can be anywhere from one zinc finger, I think, or one, what the hell is it? One DNA codon. Basically, I think are they 3 amino acids or 4? I'd have to review my stuff on it. But anyway, there are, like, the finger part of it is what varies, and that's why zinc fingers are so prevalent in the genome. They're involved in stopping transposons from killing you. They're involved in a whole lot of immune functions there's 790 of them, and they are prolific, and they all came from the same family. Actually, I think if you look at the phylogeny, it may have came from 3 different families. I can't remember. Anyway, we found zinc finger motifs in bacteria. We found them in bacteria. So, I mean, they existed a long time ago, and they've been with us for a long time. It's very easy to see how they evolve. Those the finger part of it is going to get mutated, and it's going to have a different function. It's going to glom onto a different part of the DNA. But anyway, I don't want to talk about any of this with you, Sal. That's not why I came here. And it would be cool to have conversations with you if we could proceed slowly and carefully and not insult each other. I would actually enjoy digging into some of the stuff you've come up with. And I can look into topoisomerase for you, but I'm busy doing other things. So what I recently did is the problems that creationists have had with the fusion event of chromosome 2A and 2B to form human chromosome 2, I destroyed one of their talking points, the fusion part. And I've been analyzing these two. This one chromosome, I've been analyzing it in depth. And what I came up with is the synteny between the two, the identity between these two chromosomes, between chimps and humans, is 98.6%. For a 5 million, okay, I've confirmed a 5 million character segment and came up with 98.6%. There's 120 million of them, so I've got a ways to go, and I'd have to automate the process because it took me a long time to get this information. But you can see these here, all of these vertical lines are where it's identical. And you'll find a few X's where there's a single SNP, single mutation. And you'll find, let's see, we'll find some deletions here. Well, let me see if I can find a deletion. Yeah, wonderful, Rebecca, just wonderful. Right here, there's right here you can see that there were insertions or deletions, and as it turns out, if you add all of these up, something happened to my screen.
Sorry, I'm sorry, I don't know what I did. I was trying to make your screen bigger so we could see what you're doing, but it's not working. It didn't work. I'm not going to try again.
There's something on StreamYard. I think if you click on my screen, like there's a little box on my screen.
I don't know.
It doesn't work.
I don't know.
You can make yourself. I can see you.
There we go. Okay. Yeah, I don't know. We'll figure it out another time.
Anyway,
okay.
So when you add all this up, and then the other thing I did is I found the synteny between where the genes are placed, and that's this right here. And this goes in perfect order. This is, let's see, this is the chimp. And you guys are just blocking your ears right now, right? I can just feel you.
No, but I can't see it. So what I would like, and it's almost at 3 hours.
Yeah,
so
okay.
What I would like to do is look at this myself. Yeah. Can you email it to me?
I don't know what I would email to you. They're gigantic files.
Okay.
And what I'm going to try to do on my channel is present it a little more carefully and more understandably, and I can make it big. And I would really appreciate somebody coming and asking questions where I say things that you don't understand. So go ahead.
There's some creationists that would agree with you. A lot of people
Oh yeah,
think that we're unified on that topic. I don't care.
There was a fusion. Yeah,
I,
and
I,
it
the
doesn't
other thing is,
disprove creationism.
yeah.
I mean, but if it didn't happen, it would falsify evolution, or at least evolution from a common ancestor with other primates. So anyway, I've done a ton of work on this for the last 2.5, 3 months, and I am so tired.
I didn't mean to be dismissive. Speed of sound on that. If you saw me rolling my eyes, it's like there's some creationists who would agree with you, and so I think it's kind of moot to discuss it. It's not.
Well,
Well, I think it's worthy, and especially because Mike said
the similarity.
that this would falsify. So, Mike,
Yeah.
if we looked at the evidence for chromosome 2 fusion and the evidence showed it didn't happen, would you not believe in evolution anymore?
I would have a real problem with part of evolution. I'd have to really, because I don't have an alternative. You know, I've been an atheist all my life, so I have no reason to believe in supernatural or the Bible or anything. So I don't have an alternative. But that would throw a real wrench in evolution if you could prove that a fusion could not happen. If you could prove that this didn't happen. So it'd be a way to falsify evolution. There's millions of ways to falsify evolution. There are 0 ways to falsify creation.
Well, I'm not sure that there are millions of ways to falsify evolution, because I find it to be very slippery, where it actually, whatever we find,
That's because it's so proven.
No, it's because whatever observations we make, they make a story to fit the observation.
Right.
So this tells me it's not
flexible.
Scientific. It is driven by the story.
Exactly. And the more we finding about the chromosome 2, about that specific area that they claim it's a fusion, the more we finding function in that suggests design. And also for you to believe that somehow,
let's talk about function, Junior.
For somehow for a creature to just bacteria infected, and somehow the bacteria's gene is gonna end up on your gene and it's gonna become functional. Yeah, it's a bit of a problem. It's a bit of a belief.
Yeah, DDX11L2 cannot be a functional protein. We know that. There's only one domain out of the 8 domains for dead box genes that it has. So it's just a fragment of one protein. It has some long non-coding RNA function. I found a paper just recently that you creationists are going to love. It's by Zhang in 2025, and it shows that if you have a high rate of transcription of DDX11L2, you are less likely to die of sepsis. And they found 3 other genes that are like that. But that's easily what we would expect from evolution, that these RNA fragments are going to have an effect on cells. And that's just one odd effect that is only evident when you get to old people. So it isn't really going to have an effect on natural selection. But I mean, when you talk about functionality, there's a spectrum all the way from absolutely does nothing at all other than being a placeholder to doing something useful. And everything is functional. Even if you transcribe junk DNA, you're going to create heat in the cell and you're going to warm the organism up. So I mean, everything can be construed as functional. So I really hate to talk about junk, and I call it junk drawer DNA, meaning you got a junk drawer with all this stuff, and you got all this stuff in your garage, and eventually it just locks in and you find a use for it.
It just locks in.
Yeah, it locks in. If you know anything about proteins, you'd realize how easy that is to happen. Anyway, I gotta go.
Happens.
I have an announcement. Rebecca. Oh, speed of sound. Go ahead and say goodbye. I'm sorry.
Yeah.
Okay.
Okay. Anyway, good night. Thanks for having me.
Good night.
Rebecca, I'm
Okay.
sorry I was
Good
condescending.
night.
I apologize. I'm sorry. Bye.
Good night. Good night.
Good night.
I did have an announcement.
Okay.
A peer-reviewed paper in the American Society for Microbiology affirms a work that Dr. Sanford and I wrote. So you remember that paper you found on nylonases?
Yep.
Since we started talking about it, I looked back. I got a citation. They affirmed us as authoritative and correct.
Wow.
Even though
Awesome.
and
That's great.
that falsified two major scientific papers by evolutionists, one in Nature and one in the Proceedings of the National Academy of Sciences. And also it falsified stuff by the expert witness in Kitzmiller versus Dover,
Wow.
Moore. And because he wrote this in his book and he was gushing over this false claim, we undid that. And also Dennis Venema, he recently published, and then the National Center for Science Education. So that paper you wrote, even though we got 7 rejections by editors, evolutionary biology editors of journals, and they told us, by the way, our conclusions were correct, but they gave reasons why they wouldn't publish. It's like, okay, maybe our paper sucked. You didn't like the way our formatting or the way we argued. The problem is no one has come forward to falsify this, and no one has printed it. Why doesn't someone come forward? And then when someone does come forward, you give all sorts of excuses not to publish it. And it had to be outside of evolutionary biology, someone affirmed our work. So that paper was cited favorably. And I just wanted to tell you that. I thought you would be happy to know that.
Yes, I'm very happy to know that. That's wonderful. Thank you. Well, thank you guys so much for coming on tonight. I am very exhausted. It's now getting quite late and we've been going 3 hours. But thank you, Junior. Thank you, Sal. And thank you, everybody who came on and everybody who's been in the audience. And we'll see you guys next time.
See you next time.
Monkey look kind of like a person.
Monkey look kind of like a person.
Evolution.
Monkey look kind of like a person. Monkey look kind of like a person.